Discovery, go at throttle up. Discovery, go at throttle up.
Good morning, everybody. How are you doing? Speak bold name for a 24-hour stream. Oh, that's probably not gonna happen. I'm not gonna lie to you guys. I nursed this a little too long yesterday. Yeah, I haven't slept. Like, full disclosure, I haven't slept at all. How do I do these streams? Caffeine. Caffeine. I just nursed the caffeine. I nursed the caffeine a little too long yesterday. I have done nothing but leave here, shut everything off, eat pizza, and then lie in bed staring at the ceiling for 8 hours straight. So I was in bed for 8 hours, in my defense. Hey, woke up at 5 a.m. to watch this. All right. All right. I believe Mr. Yak is on NSF, is he? Is Mr. Yak doing this? He is a good commentator. Mr. Yak. It sucks when that happens. Yeah, I always get insomnia. I think I nursed the caffeine a little too far. And, dudes, launches still pump me up, man. What can I tell you? Launches still pump me up. Still get fired. I'm still, like, waiting in anticipation. If you have to get up at a weird time for the launch tomorrow, like, or, well, now today, and about coverage begins in about 12 minutes. I'm, like, excited. It keeps me up, dude. We must yak in the chat. Someone's up early. Yeah. Hey, well. Hey, so I'm still good. I'm sharp. I made a cup of coffee because what I'm probably I was gonna try to bridge the whole thing to the flame trench. Might have to take a break, but it wouldn't be a long one. Fingers crossed for no scrub. Well, the weather window looks good. Let me go get my coffee, and we will talk more about it momentarily. Shinar, privet, tovarish, privet, tak dela. Privet. Говорит и показывает Москва. Okay, I'm back. Shinar with the 37 months. Thanks, dude. He has so much energy, he's even breaking out the Russian. Well, I got the winning plan. I don't speak French, EJ. Mon Dieu. Sacre bleu. Easy there with a coffee? Yeah. Oh, we're way past that, Jerry. We're way past that one. Bonjour, Phoenix. Comment allez-vous, mon ami? It took a second. How strong is that coffee? Bro, how strong is this thing? I stopped drinking this thing like 9 hours ago, and I'm still like, you know, like, frick that thing. That's like the caffeine toothpicks all over again. Oh, hey, look. It's me, your friend, Alarm. It's time to get up. Thanks, Alarm. Very cool. Anyway, so Vulcan Centaur Cert-2, or Cert-2. Yeah. Let's go. This is a Certification 2 mission for Vulcan. ULA, United Launch Alliance Vulcan rocket. The Vulcan is their next generation rocket. And this is the Certification 2 for it. This mission there's technically no payload. It's just instrumentation. But this is a very, very big mission for United Launch Alliance. This is the Certification 2 mission. The certification that the certification in Certification 2 is referring to is the National Security Space Launch Certification. So this is a mission that Vulcan needs to do to get it certified officially for national security missions. Big deal. This is a big deal. I don't know why they chose to do it at the butt crack of dawn, but it's a big deal anyway. Morning, boss. Hello, Tessa. You saw what happened at the Mets-Brewers game. I didn't. NG, I've literally sat in a dark room for 8 hours staring at the ceiling. Oops. Evolmente erki johansen. Eve päivi. Kelusko te teemoktaa. But terve. Mikäli. Hey, Predominant, how are you? Good morning, how you doing? Oh, I'm tired. Oh, you're gonna pay for that. Yeah. Yeah. Oh, no. I'm waiting to crash. It's gonna happen. But for now, I'm, like, good. I'm good. A little sleep deprived, a little tired, a little wired, but I'm all right. The time is fine for Europeans. Yeah, but CO10, there's this problem. I don't live in Europe. There's this problem. I'm guessing they're going as the weather tends to be better this time of year in the morning. Maybe. The weather this time of year in Florida pretty much sucks. Actually, I mean, it's actually pretty mild. Once you get into the fall months in Florida, temperature gets to like 75 every day. Not a lot of humidity, but there's these big swirly boys that come from the south, and they get angry. As long as you're the only thing that crashes. Yeah, Ben, I'm fine with me crashing and the rocket doing fine. I'm good with that. That's fine. Yeah, why you no live in Europe? I do not know. What, you're not live on YouTube yet? I didn't turn that on. Cinnamon rolls? Where, Goon? Where? I knew an Australian streamer who lived on EU time for the view count. Ando, yeah, little trick to streaming. That's actually not the worst idea. Eastern time, US, like, and this isn't like one of my US time supremacy things that I go on. Eastern time in the US is not bad. If you start at noontime Eastern in the United States, that's 5, 6, or 7 for most for Europeans, right? So you start right when you all get off from work, right? So you all get off from work, stream starts, and then prime time across basically from Europe through where I live, and then across the time zones in the US, and I basically stop at the end of prime time on the West Coast. Yeah. That's been my trick for years. It's a long grind, but it works. It works every time. Like, without guarantee. It turns out if you stream a lot and you're at least remotely entertaining, people will watch. Stream more EU times. This is great. Bruh. Yeah, NSF got it covered on the YouTube front, guys. We'll stick over here as Twitch. 12 for you is 18 for you. Yeah, that's what I'm talking about, man. Yeah. Happy Sputnik Day. Poyechali. I know that's April 12th, but da. Sputnik. Semyorka. Very good. Ben, you want me to turn that YouTube stream on? I admire your space knowledge. Thanks, Wombat. Yeah, man. Space is... Let me put it to you like this, dude. I don't even know if I like spaceflight anymore. I have no idea. It's something I just do. Like, it's like, space is just like walking. It's something I just do. Space is the place, man. Yeah, I'm not gonna lie to you. I love it. Yeah, no, that was... Yeah. It's amazing. Yep. My favorite thing in the world. Or not. Oh, yes, you do. I play Eve with Americans, and the best content starts happening from 8 p.m. GMT. Yep. Ando, that's the trick, dude. Passion is very clear. Dude, that's it. Like, when you get me going about space, I just go. I mean, you heard us talking about it. XB70s and SR71s yesterday and X15s. I love it. I can't get enough of this stuff, man. It's the best. That's why I'm here at the butt crack of dawn to watch this launch. That's why we were here at 3:30 in the morning for Polaris, man. This is good stuff, dude. It's your 12-year wedding anniversary, bro. The plane segment yesterday was great, dude. Cheers. Cheers, mate. Congratulations on lasting 12 years. 12 years of being married to the woman that you love. Good for you. Oh, yeah. Na zdrowie. I broke out the good stuff for you, mate. That hits different at 5:30 in the morning. So the ULA cast is live. Wait, get me on the screen. There we go. Yeah, I know, Mohawk. It's amazing. Yes, liquid bread. Yeah, it's like having a bagel with cream cheese. It's great. Seriously, Dominic, congratulations, man. 12 years is good. I hope to reach that level, that power level, someday. Starting the weekend early. 5:30 a.m. Guinness. Hits different, dude. It's 5 p.m. somewhere. I do believe it's 5 p.m. in Japan. You know, that hits different with coffee. Still too early for you? It's 6:37 in JP. Oh, perfect. Perfect time. When was the first Vulcan test? The first Vulcan test was a little bit earlier this year, and it launched the Peregrine, the Astrobotic Peregrine lander. Peregrine lander subsequently pressurized its hypergolic systems after separation and blew a fuel line and re-entered Earth's atmosphere. Not after going out near the moon a couple of times, which is pretty cool. Yep. It's 10:38 p.m. That beer is fine. Oh, hell yeah, brother. Why are the SRBs so small? It's not that those SRBs are small. It's Vulcan is big. It's a big launch vehicle. It's about the same size. It's about as tall as a Falcon 9. It's 22 stories tall. Those GEM 63s pack a punch. Seriously. So Vulcan is flying in the VC6. Or not VC6. VC2 configuration. So Vulcan Centaur 2. 2 SRBs. Vulcan could have up to 6. Those are GEM 63XL boosters. Graphite epoxy motor 6.3. XL. Those are big, solid rocket boosters. We have permission, by the way. Hey, Baron, what's going on? EJ looking with infinite riz today. Oh, thank you. So look at the SRB compared to the railing right here. This is actually a good picture. So, like, you and I are probably about that tall. Me, I'm like up here. So, like, a person is probably as big as my hand in this picture. That is not a small SRB. They pack a pretty good punch. Here, let me, I'll get you some exact specs. Please hold. Each one of those boosters weighs 53 metric tons or 117,000 pounds. Holy cow, that's no joke. They make 2 meganewtons of thrust. Each one of them make 2 meganewtons in thrust. They're 22 meters tall and 1.6 meters in diameter because frick you. 280 second specific impulse, 84 second burn time. Ammonium perchlorate and hydroxyl terminated polybutadiene with an aluminum stabilizer. Same SRB fuel as the space shuttle and SLS. Dude, that's not a small SRB. That's actually quite large. All right, here we go.
Good morning. I'm Andrea Linhoff,
What's up,
Systems
Andrea?
Engineering Leader at ULA and your host for live coverage of today's Vulcan launch. I'm joining you from ULA's Advanced Spaceflight Operations
clock.
Center at Cape Canaveral Space Force Station in Florida. Thanks for getting up early for the second launch of ULA's Vulcan rocket. Today's flight is dubbed Cert-2, signifying the second certification mission for the new Vulcan rocket. The first certification flight successfully lifted off earlier this year.
You love it, Baron, don't lie.
The Vulcan rocket will continue
You love it,
ULA's
boy.
legacy of support to our U.S. government, civil, and commercial customers. And with today's flight, we'll move a step
here for it,
closer to
Kalani.
certifying Vulcan for government missions. We'll learn more about certification throughout the broadcast. On board the Vulcan rocket is an inert payload along with several tests and demonstrations for future Vulcan capability.
Do we know if a Vulcan launch has enough performance to do a translunar injection? It did on its first flight. The Peregrine lander was going to the moon, Mohawk. Vulcan put it on TLI, and then it blew a fuel line.
Heard a 60-minute plan.
Now you type? Smart gals ain't you type, huh? All right. To which their own. I mean, my wife's a software engineer, I'm just saying.
Towards an on-time liftoff. Live coverage this morning will continue through second main
Glass,
engine
what's up, Shadow
cutoff,
Man?
which occurs at about 35 minutes after liftoff.
Oh, it's the shuttle. What craft would I take a ride on? It's the shuttle. Besides the obvious shuttle, if it was something else, Dragon. All day. Dragon. Oh, Tori Bruno time!
We are coming up on a very
What up, playa?
important and exciting
Dude, Vulcan
launch.
tie.
This is our second flight of Vulcan, which is also our second certification mission. This is really important to both our company and especially our customers because this flight is necessary for us to begin flying national security space missions. And there are already a pair of these in the pipeline that are vitally important to our country. Our original plan had been to fly Sierra Space's Dream Chaser vehicle,
Yep.
a really cool mission that we have been supporting them in for a number of years now. However, they're just not quite ready in this time frame, and we have to proceed in order to clear the way for national security. Don't worry about Dream Chaser, we will circle back and fly them as soon as they're ready.
Yeah,
In the
baby.
meantime, we will be flying a mass simulator, sometimes called an inert payload, and fly a very similar trajectory to what we flew on Cert-1. Because we have that inert payload, we are also free to
That's
add
awesome,
a number
Baron.
of experiments and technology demonstrations that will help us with our enhanced upper stage plans in the future. This will allow us to have more performance, to do more agile trajectories and insertions, especially for our national security space customer, as well as extend the duration of that upper stage, which is essential for a whole number of things that we will do both commercially and to contend with our country's challenges in space that are being presented by adversaries like China, and allow us to provide that kind of support that will keep space a peaceful environment and one in which our country feels secure. So this mission is coming up soon. It's going to be very exciting, and then it opens the door for whole new missions for Vulcan in the future. Thank you.
Yeah, baby. Yeah, Baron. You see that? You see that ring he has? What a Chad. Tori's the real deal. I've always respected that guy a lot. He's a good dude. Never had the pleasure though.
As we look at the Vulcan rocket on the pad, we see the American flag across
Hello.
the inner stage with the
Oh,
ULA
bring it-
and
bring
Vulcan
it back.
logos on the payload fairing. Though it's hard to see now with the booster filled with cryogenic propellants, the Vulcan logo is also wrapped around the first stage. And a portion of the booster includes spray-on foam insulation or SOFI to improve thermal protection and enhance performance.
I'll
Let's
tell you
learn
in a
more
second,
about
baby.
this innovative new rocket.
So that's a purge flame. The purge flame is there for the meth. There's actually two of them. There's a LNG purge flame for the methane, the LNG recirculation systems, and then there's a hydrogen purge flame. Ooh, nice billet, baby. Sweet. Why are those purge flames there? Well, Vulcan's first and second stage are using cryogenic propellants. First stage is using LNG, liquefied natural gas, and liquid oxygen, both very cold. These very cold propellants exist in liquid form, but because they're so freaking cold and they're at pressure, or ish pressure, they boil. So they boil off. They like to boil off, which the liquid oxygen, you just see a vent on the side of the rocket. That's the top off. They just open a vent at the top of the tank while they're filling it with LOX, and you see the oxygen go overboard. Now, you don't want to have your methane or your hydrogen near that, obviously, for pretty good reasons. The reason why, both methane and hydrogen, extremely flammable when combined with gaseous oxygen. Also very flammable. Also, when it finds the right vapor, oxygen makes stuff flammable. Let's put it that way. So the oxygen just gets vented overboard. There's those GEM 63s, though. Oh, dude, beast mode. Right? That's the Centaur 5 right there, with 2 RL-10Cs up on top. There's the payload fairing. So with the methane and the hydrogen, you have to have a recirculator, and you have to give the gaseous methane a place to vent. If you don't give the LNG and the hydrogen places to vent, so what's called a flare stack, if you don't give it that, you're just gonna leak hazardous gases all over the place. Because if you don't give it a place to go, it's gonna find a place to go. There's the hydrogen purge over there, and then the LNG and methane one is the one you saw in the background. It's over there. The hydrogen purge flame for the second stage, because the second stage commodities are over here, is right there. See the double stacks. So yeah, that's why those flames are there. They're there to purge out hazardous gases from first and second stage fueling operations. Flare stack for the methane is over there. That was all added. Yep, there it is. See, it's on fire. That was all added as part of Slick 41's upgrades for Vulcan. Slick 41 had just, there's hydrogen, there's the LNG, right? You see the two flares? But yeah, that's what they're there for. They're a purge flame. Hold on.
Stating weather is great for our launch this morning. And if we take a look at radar behind us, we can see we've had just enough dry air move in over the past 24 hours that has pushed most of our storms and showers that are happening overnight down to our south. The little bit of activity we have up across to our east over the Atlantic Ocean remains a little too shallow and a little too far to our east to be a concern here over the next couple minutes. Our main area of concern here is within this white ring, which represents 10 nautical miles. So if we go here and take a look at our forecast here, we're going to only be looking at a POV of down to just 5% with no significant launch weather concerns tracking. Winds are going to remain from the east, this light breeze about 10 to 15 knots, with temperatures around 80 degrees this morning.
Gotcha, baby.
Weather looks great for the launch. And back to you, Andrea.
Yeah, Shinar. So Vulcan's first stage has two B4s. They're actually made by Blue Origin. It is a oxygen-rich LNG stage combustion. So think like a methane RD-180 on steroids. Those engines are no joke. 2,400 kilonewtons each. The Vulcan packs a punch for a small rocket. It's pretty damn good. That's flanked on the outsides by 2 GEM 63XLs. They make 2 meganewtons of thrust each. So this thing, for a seemingly small rocket, makes a pretty good amount of power. This thing is pushing 9 meganewtons. So those 4 engines, those 2 SRBs, 2 B4s, are making about as much as 9 Merlin engines, give or take. It's about the same as a Falcon 9 on liftoff in the VC2 configuration. Vulcan can launch with 6 SRBs. Now, the upper stage, like you asked, that is a Centaur. It's a Centaur 5. It's so the 5th generation Centaur, 5-meter diameter. That is 2 RL-10C variants. I'm not sure what the exact C variant is. I think it's an RL-10CX using additive manufacturing. They laser sinter aluminum those RL-10s. They're really, really good. If it's using the ones that I'm thinking of. I don't know the type off the top of my head. I know they're RL-10Cs. It's got 2 of them in the upper stage. And the second stage is it's a Centaur, so stainless steel, balloon tank, hydrolocks. Which is why, once again, you have double purge flames. That's the hydrogen one burning that bright orange, and that's the LNG one over there. It's funny because those purge flames show exactly the difference between hydrogen and LNG. LNG, you notice that LNG flame's a lot bigger. It's way bigger. LNG has a lot more, it lets out a lot of energy faster, which is why they're using it as a first stage. And then the hydrogen, you know that's it's a little tiny thing. Hydrogen burns very efficiently though, which is very interesting. It kind of shows that, and hydrogen always burns like super orangey, like that. Unless, I mean, that's obviously gas, fuel rich right there because it's orangey. If you burn hydrogen real efficiently, it's clear, like a shuttle engine, or like an RD-0120.
Discovery, go at throttle up.
I think they're CX, Ben. I'm not 100% sure. I'd have to go look.
This is Vulcan Mission Control at T-minus 7 minutes and holding. You'll frequently see today that there's a VC2S for our configuration that we're flying. The V, the first in this configuration, stands for Vulcan. C, the second, is our Centaur upper stage. 2 indicates the number of solid rocket boosters, so for today that's 2. And then S is standard, and that is our payload fairing length.
Higher exhaust velocity with hydrogen. Yeah, absolutely. So there's an RL10C variant on there right now, but they're eventually using Aerojet Rocketdyne is using Vulcan to develop the CX. That's the additively manufactured one. That's gonna be a huge game changer. Because the RL10 is already good, but 3D printing it makes it even better because of how the exhaust flows through the 3D printed material. It's nerd stuff. Don't worry about it. It actually makes it more efficient the way they make it additively as opposed to making it brazed like how they do now. The CX is nuts, dude. Yeah, CX is no joke. That's gonna be a pretty damn good Vulcan. Pretty damn good variant of Vulcan, excuse me. The hold is a planned hold, guys. They should be popping out of that hold actually very soon here. Remember, the launch window opens in 6 minutes. No YouTube stream. NSF was handling on the YouTube side Gistall. I mean, I could pop it on if you want, but yeah, no. I'll upload this VOD to YouTube. If you're watching this on YouTube, hi YouTube VOD viewers. How are you? Thank you for watching. Appreciate it. Hopefully we get the channel monetized soon. They said they're pushing back by a few minutes. Teeds need an extra few minutes. Yeah, the window opens because they would have released the hold now if they were go. That's correct, Ben. Yeah. Oh, here we go. Hold up.
This is Vulcan Mission Control at T-minus 7 minutes and holding. The Vulcan launch vehicle experienced a data dropout, which caused the ground systems to stop propellant flow to the rocket. The team has configured the systems to resume flow, and we are working to establish a new T0 shortly.
That's not great. Yeah, that's not great. Probably going to want to figure out why it did that. That sounds like undervoltage. What was that? So it sounds like they went to go initiate the count and they had a data drop on telemetry from the vehicle, Tessa, and that stopped propellant flow cycles. So Vulcan left the top off cycle, but now their mission control is reinitiating the top off, which is why that big vape cloud coming off is a little bigger than normal, and why the flame is kind of angy. We'll see what happens. Yeah, they lost data. They lost the telemetry connection to the vehicle. That's not great. You know what? I don't like my head being on fire, so I'm gonna go over here if you don't mind. Top of the morning to you, Delicious. How you doing this day, boyo? I got me coffee. Oh.
This is Vulcan Mission Control at T-minus 7 minutes and holding. Building on more than 130 years of combined Atlas and Delta launch experience, ULA's Vulcan rocket introduces a balance of new technologies and innovative features to ensure a reliable and accessible space launch service. Let's hear more about this incredible launch vehicle.
I would like to hear what's happening now.
Vulcan Centaur production begins with aluminum sheets, expertly machined to remove more than 2/3 of the weight, resulting in the structurally strong yet lightweight orthogrid panels that form Vulcan's propellant tanks. The panels are then bump pressed to form the curves required to complete the tanks. At the same time, rings, adapters, and other structural components are precision milled.
Billet.
Next, the aluminum domes, panels, and other structures that form Vulcan's propellant tanks are first cleaned and etched to a smooth, even surface, and then anodized to harden and prevent corrosion. Following an ultrasonic inspection, 5 completed panels for the liquid methane tank are assembled and joined together
Look at that.
using friction stir
roll
welding.
toads, fellas.
Unlike traditional welding, where filler material is used to join components, friction stir welding uses a head to stir the metal of the 2 panels together as it moves down the seam. The resulting joint is stronger and produces a lighter weight, higher performing tank. The process is repeated to create the liquid oxygen, or LOX tank, followed by attaching domes to complete the tanks. Circumferential friction stir welding is then used to join the 2 propellant tanks that comprise the Vulcan booster.
That's pretty sweet.
As production continues on the booster stage, stretch-forming gore panels for the Centaur's second stage propellant tanks is underway. The stainless steel gore panels are welded together to create the propellant tank domes. The gore welder is one of several highly specialized welding stations in the Centaur production process. Just down the aisle, Centaur 5's massive intermediate bulkhead is mated to its ultra-thin tank. Once both propellant tanks are welded, they're mated together to create the Centaur 5 second stage. Before moving to final assembly, the 5.4-meter booster is sprayed with foam insulation, followed by booster mask and paint. Twin BE4 engines are individually hot-fired prior to making their way to the factory. They are then mated to Vulcan's thrust structure and protected by a heat shield. With production complete, Vulcan's first and second stages depart the Decatur factory and make their way to ULA's rocket ship to begin their journey to the launch site. Following the journey to Cape Canaveral, the Vulcan components are offloaded from rocket ship and transported to a vertical integration facility, or VIF, where they are lifted onto a Vulcan launch platform, or VLP. The vehicle then travels to the pad, and the launch team transitions to fueling and other final preparations.
All right, Drummer. That was Cert-1 right there. All right. See if we got an update here. Oh, God.
LC. Go. Countdown clock has been reset with a new T0 of 10:30 Zulu. We are currently at L-29 and counting.
30-minute delay.
Roger.
They're targeting a new T0 of half past the hour, so 6:30 a.m. Eastern Time. Why the delay? They lost data stream from the vehicle when they tried to initiate the count for the first, to target the first T0 at the opening of the window.
RC. Go. The range has approved our new T0 of 10:30:00 Zulu.
Roger.
Range confirms new T0 time. RC is the range coordinator. LD is the launch director. Joe, it'll be all right.
This is Vulcan Mission Control at T-minus 7 minutes and holding. A new T0 has been identified at 6:30 a.m. Eastern.
See?
Perform Centaur LO2 fill and drain valve cycle test. Roger.
They're going to make sure that the
Fuel
cycling...
2, perform Centaur LH2 fill and drain valve cycle test.
They're going to test the cycling because they shut off when they lost the data stream. They're making sure that that still works.
Roger. Fuel 2. Yeah, okay. You copy. Fuel 2, LC.
Go ahead.
And I just wanted to ensure you copied the transmission to re-perform the fill and drain valve cycle.
Affirmative.
Roger. Has gas, establish scan patterns 62 and 63. Roger.
The has gas is the venting systems. The has gas venting systems leads to the purge flames, dude. So that was the launch director telling the second stage fueling people and the fuel and oxidizer people to turn the fill and drain valves on and off, to cycle them. Those are the valves that permit the second stage to be filled with liquid hydrogen and liquid oxygen. And then he after that he told the has gas people to do the same thing. So Vulcan was originally supposed to launch about 3 minutes ago, and they went to initiate final count, and the vehicle lost all data streams, and that put the vehicle into kind of a safe mode where it shut all the topping valves. So it took the vehicle out of what's called recirc. In recirculation mode, guys, because Vulcan is fully cryogenic top to bottom, so on the second stage you got liquid hydrogen, liquid oxygen. The first stage you got LNG.
This is Vulcan Mission Control at
LOX.
T-minus 7 minutes and holding.
You have to keep topping off.
Launching rockets takes the coordination of a team of experts.
You have to keep topping off because they're boiling. So that, once again, we talked about the has gas purge flames. That one's for the LNG, and then there's another one for liquid hydrogen. And the liquid oxygen vents are just on the vehicle. That's what those clouds that you see coming off the vehicle are, first and second stage. They just vent the oxygen overboard. No one cares if you vent oxidizer overboard. More oxygen in the atmosphere is, I don't think anyone's going to complain. But the hydrogen and methane, if you don't give it a place to vent, and you give it a place a flame to purge it out, it'll find a flame to purge it out, and it'll blow up somewhere you don't want it to. So when you're in recirculation, because the propellants are fully cryogenic, because they're so freaking cold, at the pressure that they're at, they boil. So you have to keep topping them off. So when they lost data stream to the vehicle shut all the recirculation systems off, and the vehicle started to boil off the propellant inside. That's no good, obviously, because if you just left it there, all the propellants will just boil off. Like if you just left a pot of water on the stove and you just walked away and did your thing, it'll boil off till there's nothing, till you just have a heated. So you just have a pan full of heated. That's just heat. It would just boil everything off. The propellants do the same thing. If you just left it there, it'll overpressurize the tanks. Once again, not that big of a deal. Losing the data stream is the big problem, but the launch director, we heard him talk about opening the valves to those lines right there on the side of the vehicle to make sure that they're still working. So we'll see.
Being the coach of a sports team, and that is when you kind of face challenge after challenge, and you have to ensure that you keep your team in the right mindset.
Yeah, there you go.
Keep their heads in the game. We've had multiple launches. I can think of 3 or 4 off the top of my head that have just been absolutely wild campaigns.
I missed Delta 4, man.
We had a launch window that was in late afternoon in the middle of the summer. We had 4 launch attempts in a row, and the weather just was not cooperating
Hey,
with
Rick.
us.
Morning.
Day after day, the weather pattern was repeating, and we came in day after day and loaded the rocket and tried again and had the rocket ready, and the weather just wasn't going to let us go. At that point, you're almost like a coach reminding the team at halftime. It's like, look, we're not out of this game. We have to keep playing, and eventually we'll
baby.
prevail. And we did.
That was the AFSPC 04.
You know, no matter how many dozens of
mission,
missions that I've
We watched
executed, it never gets old. And when we pick up the terminal count, my heart rate definitely goes up. It's exhilarating every time.
Badass, man.
It never gets old, and I hope it never gets old because I really love watching it.
Yeah, I know what you mean. Send it. Yeah, baby. Yeah, that LNG flame is going pretty hard over there. That's the LNG purge line for the first stage over there. That's what that fire is. The hydrogen purge flame is off screen on the left. Once again, that purge line is for the first stage over there for gas purging, liquid fuel hazardous gas purging on the first stage over there, and second stage gas purging is over there. Could they scavenge it? Yeah, you could. Could. It's to the point where it really doesn't make a lot of sense. You're not boiling off that much, dude. Like, you're not boiling off enough of it for it to really matter.
This is Vulcan Mission Control at T-minus 7 minutes and holding. ULA builds Atlas and Vulcan rockets in a 1.6 million square foot facility in Decatur, Alabama. Here's a look inside.
Okay. Oh, hello. Love that camera.
Successfully launching missions to every planet in the solar system, in addition to critical national security, science, weather, and communication satellites. ULA has established a long-standing industry reputation for reliability and orbit accuracy. While our rockets lift off from launch pads in Florida and California, the journey to space begins in Decatur, Alabama. At approximately 1.6 million square feet, ULA's production facility is an always-on workhorse where technicians simultaneously build components for Atlas V, Delta IV Heavy, and Vulcan Centaur rockets. Booster production begins when large aluminum plate stock is loaded into one of 4 double gantry skin milling machines, where aluminum is milled into patterns designed for building tanks and other components. This process helps reduce the original weight of each panel by 70%, while maintaining approximately 75% of the original material strength. After machining, skin panels are transported to the brake form and bump pressed into the precise curved radius required to create fuel tank barrel sections.
So that's that's called an ortho grid, guys. It's a milled ortho grid. That's an ISO grid. The ISO grid is triangles, so that's an Atlas V. That's part of an Atlas V. If you see the squares, it's Vulcan. The milled aluminum ortho grid is really strong. That's ortho grid right there. It's the rectangles.
And forged together to form the barrel sections of the fuel and oxidizer tanks.
So that's what you have right there. What we have here is failure to communicate. No, that is a vertical friction stir welding jig. Basically, they have a metal cylinder that spins, and it spins on the seam between the metal panels that they make, right in that vertical jig right there. So you see the stir welder going up and down right there. You see it go. What it's doing is that the head is stirring over the gap between the panels, and what it does is it introduces enough heat from friction that it actually it melts the aluminum locally and it stirs it together. That's why it's called stir welding. It basically mixes it together. The reason why you use a stir weld, first and foremost, you're not adding any material to the vehicle. Weld welds a lot of mass. If you're using a MIG welder, right, to MIG weld these panels, or a TIG welder, you're adding mass to the vehicle. With a stir weld, first and foremost, you're not adding extra mass to your vehicle. So vehicle it's lighter actually this way, believe it or not. Second thing, the molecular structure of the joint between the two panels basically becomes one. It's consistent all the way around the circumference of the vehicle with a stir weld. When you use a TIG weld to weld aluminum, right? Once again, you're introducing material. There's the stainless steel being stretched over a jig like you'd put saran wrap over a plate. Yeah, the stainless steel is not very thick. It's about as thin as a soda can, to be honest, on Centaur. When you like TIG or MIG weld aluminum, the way you do it, like, because with a TIG welder, you're putting the rod you're arcing it through the tungsten beam, through the beam from the tungsten, right, from the welder. The way you do that actually is different than how the metal was made, right? So you're going to get different molecular structures between your metal and different material, right? A stir weld keeps the material consistent. That stir weld mixing it together might as well make it one panel. So stir welding affords you lighter mass, right? And it also affords you a more consistent structure all the way around the vehicle, rather than the welds being the strongest part, right? You're much less likely to get a failure because you have a consistent molecular structure of the metal all the way around the circumference of the booster, right? There's that freaking L9000, man. What a sweet freaking truck, right? That's why you stir weld. Stir welding, the application of rockets, is actually something that NASA designed for the shuttle's external tank, because in the 80s, they were trying to shave off weight from the ET. So stir welding was pioneered in the applications of rockets by NASA on the LWT, the lightweight external tank design, which shaved, I don't know, like 2,000 pounds of weld off of the tank or something, like 1,000 kilos of weld, because you don't have to add anything to stir weld. You're just actually stirring the aluminum panels together. It's super trick. Everyone does that. SpaceX does that. ULA does that. SLS does that. New Glenn does that. Everyone stir welds because it's the best way to do it. You're going to get uniform consistency on all of the tanks. And in order for the tank to stay nice and structurally rigid, if you have a consistent molecular structure around the circumference, because you have pressure pushing on it on all sides evenly, you're going to get a really, really strong tank. You can hold stuff at higher pressure. It's really, really, really smart. How old is the Centaur family of stages? The Centaur 1, the original Centaur 1 variant started flying in 1962 on an Atlas Centaur, believe it or not, from Slick 36.
LC problem.
Oh.
Go.
SGI charge to flight pressure.
Roger.
SpaceX.
minus 16 minutes.
16 minutes. SpaceX tip and TIG weld Starship, stainless steel. ULA does too. You can't really stir weld stainless. I mean, you could.
This is Vulcan Mission Control at T-minus 7 minutes.
Stainless doesn't do good with the heat.
Earlier this week, the ULA team conducted an extensive practice ahead of today's launch attempt. We're looking at video of the wet dress rehearsal. The WDR is a full day of launch test. During the WDR, Vulcan's booster and Centaur stages are powered up. Avionics are tested and final preps to the ground systems are accomplished. Next, the rocket is loaded with methane, liquid oxygen, and liquid hydrogen. With the rocket fueled, the team proceeds into the terminal count, which includes pressurizing the rocket, arming various systems, and transitioning the rocket to internal power.
I do believe this happened
on
Tuesday.
The WDR count ends just seconds prior to T0.
Yep.
The rocket is then safed. The cryogenic propellants are drained.
PNE-1, initiate post-liftoff launch head umbilical purge autofile.
Roger.
That's a pretty awesome camera. Hey, Vulcan Commander here. I was wondering if we could launch these a little later because I'm sleepy. Yeah, tell me. Me too, man. It's hard balancing that satisfactory addiction with all these launches, especially when they're at frick you o'clock in the morning, man. But anyway, it's good to see you, buddy. How are you? Spoon, you're driving down to Atlanta today.
Oh, minus 14 minutes.
Time to see how good of a streetcar she is at 1,000
Prop 1,
horsepower.
perform G&G snuffer purge cycle test.
Roger.
Sorry, Spoon, I missed your resub, dude, but that's sick.
LT, OSM 1.
Go.
First step, 1040. Launch sequencer overrides established.
Roger.
Sequencer overrides.
LC, PNE 2.
Go.
CUC airborne pre-chills complete. Recorded time 10:16:13 Zulu.
Recording 10:16:13 Zulu.
Good copy.
It's frick you o'clock for me, dude. Sequencer overrides are not something you want to hear on a second launch. I mean, it doesn't seem like it's that big of a deal. I'm sure that...
Oh, minus 13 minutes.
Sure that ULA has a contingency, but sequencer...
Flight control, perform launch on time, verification.
Roger.
OSM, place SRB ignition S&A switch in the enable position.
No, Centaur is not stir
SRB
welded.
ignition enabled.
It's
Verify the
tip-welded.
FCO, ROC, and OSM hold fire switches are in the proceed position.
Ready to proceed.
RC, verify solar radiation acceptable for launch.
Verified.
Range coordinator says good space.
PNE 1, verify post liftoff launch head umbilical purges configured for launch.
Verified.
Okay.
LC Prop 1.
Go.
G&G snapper bird cycle test complete.
Roger.
LC flight control.
Go.
Launch on time verified.
Roger.
Okay.
Oh, minus 12 minutes.
We have an inert payload on board today, Red. This is a certification mission to make sure that Vulcan is good to go for national security missions. That's why it's called
RLM, verify red line monitor and event table in the correct configuration for terminal count.
Verified.
The red line monitor, in case you guys are wondering, is the person that basically has all the...
Centaur LO2 at flight level.
Roger.
Centaur
LC
LOX
Field
is at flight.
Go.
Centaur LH2 at flight level.
Centaur hydrogen is at flight level.
Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold.
Not what we want to hear at this point, but yeah, that was just a all points bulletin. They're not cops. You get the idea.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
You heard that, chat. You heard him, chat. Be quiet. Oh, frick. I'm starting to crash. Not good. This thing better go.
All steps complete prior to the status check. LC switch ready.
We remain in the hold as we continue towards liftoff.
Shut
In a
up,
few
man.
moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the count. 29 engineers and managers are pulled for
Slick
system
41
status
pad.
and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground
Oh, yeah,
systems,
Ben.
and the
No
U.S.
regrets,
Space Force
dude.
Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan
Probably
Rice
not
performs the
hypersonic.
final polling.
What time is it where I am, Tiger Claw?
Oh, minus 10 minutes.
6:20 in the morning. Same time as Florida.
Status check to proceed with terminal count,
Okay, here
Vulcan
we go.
systems, propulsion,
Go.
hydraulics,
Go.
pneumatics,
Go.
LNG,
Go.
Chat.
LO2,
Go.
water,
Go.
Centaur systems, propulsion,
Go.
pneumatics,
Go.
LO2,
Discovery, go and throttle up.
LH2,
Huge
Go.
crit.
has gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS.
Go.
Flight control.
Go.
TCQ.
Go.
Op support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1030 Zulu.
Okay, here we go. So I was saying...
ABE, issue MRQ.
And the team is go for launch. From T-minus 7 minutes until liftoff, you'll hear Dylan Rice and the team performing the final steps in the countdown procedure.
So I was saying what the red line monitor does. The red line monitor basically has all the telemetry from all the master telemetry from all those different positions in front of him. It's a control board, and if any part of the telemetry goes into what's called the red, basically off nominal, the red line monitor will call it. Yeah, that's what an RLM does.
Go Cert-2. This is the final status check of the rocket and payload readiness. At T-minus 6 seconds, initiation of the launch pad water deluge system occurs. At T-minus 3 minutes, the main engines ignite. Then after seeing Vulcan lift off from Slick 41, you'll begin hearing flight commentator Hannah Peters providing launch vehicle ascent data.
As gas, establish scan pattern 71.
Roger.
All steps complete prior to terminal count.
Hey Shaw, how you doing, buddy? Should be releasing that hold there up in the top left here momentarily. Should be coming out of the hold like in the next 10 seconds. Should be.
This is Vulcan Mission Control at T-minus 7 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 7 minutes and counting. 3, 2, 1, mark.
Hold released. Good news.
6:55.
The countdown clock is resumed and we are go for launch at 6:30 a.m. Eastern. After liftoff, ULA's Vulcan rocket will head southeast from Space Launch Complex 41. Here's a look at today's ascent.
Following final confirmation of rocket readiness, twin BE-4 engines and 2 GEM 63XL solid rocket boosters produce more than 1.8 million pounds of thrust to lift ULA's Vulcan rocket away from Cape Canaveral Space Launch Complex 41. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Vulcan then reaches Mach 1, the speed of sound. With the ability to add 2, 4, or 6 solid rocket boosters, or SRBs, Vulcan can be precisely configured to take any mission to space, from low Earth orbit to Pluto and beyond. These boosters augment the rocket's total thrust at liftoff, adding approximately 460,000 pounds of thrust per SRB. With their propellant expired approximately 90 seconds into ascent, the SRBs burn out, followed by jettison. Jettison time is variable, occurring between 100 and 150 seconds after liftoff, depending on mission requirements. Vulcan's guidance system then activates to steer towards the precise target in space. First stage flight continues as the rocket crosses the Kármán line, entering space. With the majority of propellant expended as Vulcan fights against the force of gravity, the BE-4 engines shut down and the booster stage separates. With the rocket now weighing less than 10% of what it did at liftoff,
did you see
dual
that?
RL-10C engines on ULA's Centaur upper stage ignite.
Wait a minute, back that up. What's going on there? What's going on with the nozzle?
for a coast phase. Further into flight, Centaur ignites for a second burn, powering the vehicle into a hyperbolic injection orbit. Following the second main engine cutoff, ULA Centaur will continue into an orbit around the Sun.
I have plans for everything.
410.
Okay.
Knowledge conditioning complete.
That's good news. Hey, program, you're just in time, buddy. 4 minutes. Hyperbolic injection. Why use hyperbole? It's pretty amazing on its own. They like to oversell. They like to oversell it. Rockets are pretty cool. A little short compared to some of the things we've seen. How tall are
Hydraulics at pre-launch.
About the same size as Falcon 9 crustacean.
This is Vulcan Mission Control at T-minus 3 minutes and 22 seconds. Following liftoff, viewers watching in Florida may be able to see Vulcan in flight as it heads east. To get a closer look at this map, check out ULA Launch on social media.
So, I don't know if you guys noticed, if they go back to that view from the BIF, you notice that there's 2 hydrogen flare stacks. Both of them are on. Anybody know why? They're on because the launch director called ullage pressures to be okay, meaning they can evac the purge system. So they turn on 2 of the flames to get all the haz gas out of that purging system quickly because it's going to launch soon. There's 2 of them. One was on before, now there was 2. One of them will go out before the thing launches, pretty sure. And they also had a LOX purge line right there. See it? You could still see it venting a little bit of GOX there. There you go, Nader. Two minutes and counting.
T-minus 2 minutes. The launch vehicle, ground systems, and eastern range are go for launch. For those of you just joining us, I'm Andrea Lenhoff, your host for today's live coverage of ULA's second Vulcan rocket launch. At this time, the team is not working any issues, and we're proceeding towards an on-time liftoff at 6:30 a.m. Eastern.
T-minus 90 seconds.
Clocks have stopped at T-minus 1 minute, 51 seconds.
Oh, nope. Scratch that. Clock stop, T-minus 150. They did not call a hold. No one called hold, meaning that it was the auto sequencer. It's a 3-hour launch window. I'm gonna be here for a while, aren't I? Oh no. That's not good, man. That's not what you want to hear, but gotta figure out why. Now you play the troubleshoot game. And this isn't like IT where you just turn it off and turn it back on, even though that's
LC, this flight control.
Sometimes works.
Go.
Flight control is ready to reset the clock to T-minus 7 and holding.
Roger.
They're
ALC, reset the countdown clock to T-minus 7 minutes and holding.
They're going to reset it to the 7-minute mark to try and put the vehicle back into configuration before the auto sequencer was started. That's why one of the
LC,
first...
Peony 2.
Go, Peony 2.
Centaur, LH2 and LO2 tank venting in progress.
Roger.
Yep.
LC, Peony 1.
Go.
Vulcan tank pressures are stable.
Roger.
So what they're going to try to do here, first and foremost, if the vehicle did something, if it said no,
the countdown clock is reset to T-minus 7 minutes and holding.
the first thing that they're going to try to do is put the vehicle into a safe mode. Not like
This flight control.
not safe mode like your computer. Put it
50 SS VAPs in active SCS in pre-flight mode.
Roger.
Return the vehicle to the mode it was in before you initiated auto sequence. That's what they're trying to do now. We did not hear a hold called over the loops, guys.
This is Vulcan Mission Control. The team has reset the clock to T-minus 7 minutes and holding. We are waiting for more information on an updated T0.
Meaning it was an automated system. If it was not, it was, the auto sequencer just said no. But interestingly enough, it was a good ways into the auto sequencer start. 150 is what they called. So the clock up here didn't see it, and we didn't hear hold on the loops. Clock kept ticking to about T-minus 90 seconds, and then they took it away.
LC Peony 2.
Go.
Centaur tank pressures are stable.
Roger. OSM, place SRB ignition SNA switch to disabled position.
SRB ignition disabled.
They cut the connection to the igniters on the GM63s. I'm drinking water in case anybody's wondering what I'm doing. I'm trying to stay awake.
All stations recycle systems back to T-minus 7 and holding configuration.
Yep.
Hold occurred at T-minus 1 minute 51 seconds. Report status at completion.
Yep, see. They're
Airborne electrical LC.
returning the rocket into the last stable state.
Transfer transmitter battery external.
Roger.
Plugging the rocket back into the grid so they can keep the batteries charged on the vehicle. We had a hold drummer, but it's a 3-hour launch window. They still got an 2 hours and 28 minutes. Any particular reason? We haven't heard why. It wasn't. Nobody called hold. Nobody called 3 holds over the countdown net, which tells me that it's an automatic system. Note that they're back basically to 1 purge flame here. See how the other one's really small? Because they went back into circulation and topping. They went back into topping mode. The GOX vent on the vehicle is going like crazy. See that? And they're back to 1 flare. So the purging flare right there that they use to evac the hydrogen, the gaseous hydrogen out of the system when the tanks are topped off, has stopped. See that flame's going away, but the other one's burning bright. And then that vent on the umbilical tower, the one that says ULA,
LC-PNE1
is going again.
Go.
First step 260, substep alpha, PNE1, Vulcan pneumatics pressure stable.
Roger.
Pneumatics pressure is stable.
LC Peony 2.
Go.
Step 260, substep Foxtrot, CEC active.
Roger.
And substep Golf, sensor pneumatic system stable.
Roger.
LC Prop 1.
Go.
For step 260, substep Delta and Echo, Vulcan propulsion and hydraulic system stable.
Roger.
LC ECS.
Go.
Step 260, substep Oscar, ECS set point stable.
Roger.
LC SYS.
Go.
Step 260, substep Mike, GC3 ready.
Roger.
LC Fuel 2.
Go.
For substep Juliet, Centaur LH2 continuing topping.
Roger.
You see they're back in the top off mode. And Debs, how are you? They're not coming out of the hold port. Guys, whatever it wasn't immediate. It wasn't something whatever. Like I said, I'm pretty sure because we didn't hear it over the loops that it was probably an auto sequencer. The
LC, airborne electrical.
This LC.
Step 260, substep Papa, airborne electrical ready.
Roger.
What we're hearing over the loops here, this is the main loop. What we're hearing is just them making sure that the vehicle's topped off and it's in topping mode, which is basically where it was before they released the hold. The AC is probably talking with the LD. The anomaly chief is probably, and the red line monitor, if the red line monitor caught anything, it's probably talking. Probably talking with the launch director.
Continuing topping.
Yeah, see, they're just back into topping and recirc.
LC, this flight control.
Go flight control.
Substep Lima, flight control ready.
Roger.
Bob? We haven't heard a reason as to why it pulled it, but once again, we didn't hear holds called over the countdown
LC
net.
has gas.
Go has gas.
For Substep India, has gas ready.
Roger.
This is not NASA, this is ULA. This is a Cert-2 mission. ULA is making sure that their Vulcan rocket here, Bob, is certified for national security missions. This is a test flight. There's not too much payload on board. There's a couple of small satellites, but the payload fairing is pretty much empty. Oh, that's Julia. Nice. Yeah, you could tell it's a ULA rocket because of the way it is. That's pretty neat. Oh, God. I picked a heck of a day to get insomnia. There's a small mass simulator, Marius. It's an inert payload. Does it know where it is?
Fuel 1.
No, not right now.
Go.
Step 260, substep Charlie, Vulcan LNG, continuing topping.
Yep.
Roger.
Day 3 for you. Bob, I haven't slept since we last talked. I went to bed after Space News last night, you know, thinking I'm being all nice and responsible, and I lied down in bed, and I stared at the ceiling for 8 hours straight. Body said no. I think I nursed this
LC ROM.
a little too long.
Go.
Op 100, step 260,
Oh,
substep
my own fault.
November, complete.
Roger.
We'll see, Rick. We'll see. We'll see. We're gonna play Satisfactory today, but I might need to take a couple hours break to go catch a nap. I can run off 2 hours. I mean, I'm gonna pay for that later, but rocket launches, man. Rocket launches, homie. I'll get second wind here in a second, dudes. Yeah, we'll catch second wind. I go for a jog. Cold shower is the trick there. If you really want to wake up. Ice
This is
cold
Vulcan
shower.
mission control at T-minus 7 minutes.
You'll
and
shock
holding.
your system.
While
It'll
we
work.
await a new T0,
You'll pay for it later,
RS
though.
rocket ship, ULA's specially designed cargo ship, delivers our rockets to our launch sites in California and Florida. Let's take a look at this unique capability.
The unique capability that NASA also has? No, rocket ship's pretty cool. It's actually in port right
Hi,
now.
I'm John, captain of ULA's rocket ship.
Yeah, baby.
Recently, our travels took us from Decatur, Alabama, to Cape Canaveral, Florida, where we picked up more cargo. And then our final destination was Vandenberg Air Force Base in California via the Panama Canal.
Hey, John, where are you from, guy? I
The
know
rocket
my
ship,
people when I
nestled
hear it.
298 miles up the Tennessee River, takes on the Delta Heavy rocket for United Launch Alliance. The trip begins at an elevation of 556 feet above sea level.
He's Mass Maritime, dude. I know that accent
23
anywhere.
miles below Decatur is Joe Wheeler Lock and Dam.
Joe
It
Wheeler.
is our first of 4 locks operated by the Tennessee Valley
Made me
Authority
so
on
happy.
the Tennessee River that allows a step-down staircase of 48 feet in level. Now into the Wilson Pool, we transited approximately 2 hours to enter the Wilson Lock chamber, the highest single lift east of the Rockies. Once secured in Wilson Lock, we were now lowered a
Ship have
distance of
smart park?
approximately
No,
90
that's why
feet.
he's there. He gets to pilot it. It doesn't have
Exiting
smart
Wilson
park.
Lock
What are
and
you,
Dam
dumb?
is a narrow channel for 5 miles that leads us generally shallow water past Florence, Alabama. Now passing Florence, Alabama, the rocket ship transits a shallow region with a rocky bottom. The crew expects 5 more hours of transit to Pickwick Lock and Dam. This trip, the vessel anchored above Pickwick Lock for daylight transit-only requirements through the lock. This was due to higher than average water and fast current conditions.
He hasn't lived
At
in
morning
Boston in a long
twilight, the
time.
ship approaches Pickwick Lock. The vessel will be lowered approximately 48 feet, and the transit continues in a narrow stretch of the Tennessee River for 106 miles, commonly referred to as the Wiggles. After passing New Johnsonville, Tennessee, the vessel enters the region known as the Land of Lakes, commonly known to the crew to be more relaxed in a buoy channel leading to the Kentucky Lock and Dam. This elevation drop is approximately 43 feet. After locking and a transit of 21 miles, we leave the Tennessee River in our rearview mirror and join the Ohio River.
That's dope.
The vessel now is located in Paducah, Kentucky at an elevation of 320 feet above sea level.
Super cool.
The deck crew returns to normal sea watches since the portion of the trip will transit over the lock and dam at Olmsted by a buoy navigable channel. After 5 hours of transit on the Ohio River, the vessel turns southbound on the lower Mississippi River, approximately 14 hours away from Memphis, Tennessee, and approximately 2 days from Baton Rouge. Other major cities along the route are Greenville, Mississippi, Vicksburg, Mississippi, Natchez, Mississippi, and finally arriving at Baton Rouge, Louisiana. There we anchor for fuel replenishment. We now have accumulated 1,070 miles of river and dropped in sea level of a distance of 546 feet to nearly join sea level.
Anchors.
Passing New Orleans by night is an impressive sight of lights from the water's edge to the tall office buildings to include the twin bridges known as the Crescent City Connection. The Federal pilot disembarks at the Southwest Pass Sea Buoy as the journey continues to Cape Canaveral.
This is super
After
cool,
crossing
actually.
the Gulf of Mexico, traffic conditions are generally light. At Dry Tortugas, the southernmost point in the continental United States, the ship joins the Florida Straits and follows the Florida Keys to the Atlantic seaboard.
It was an automatic hold. Yeah, great.
The rocket ship finally arrives at Cape Canaveral, completing a sea voyage taking 3.5 days and approximately 8.5 days from Decatur, Alabama. Departing the dock, the journey to sea is a short 7 miles. The pilot disembarks and the transit continues for slightly more than 3 days. We begin approaching Gatun Lock with a complement of Panamanian linemen. Gatun, the first lock, has 3 chambers.
Oh, dude, that's the Panama Canal. That's killer.
Next is Pedro Miguel Lock with 1 chamber, and last, Miraflores Lock has 2 chambers. Signing out with the authorities at Flamenco Single Station, the ship enters briefly into the Gulf of Panama and enters the Pacific Ocean with 12 days of voyage ahead. The crew maintains bridge watch activity, engine room assignments,
Those
as
are the
the
old
deck
locks,
crew
Beefy.
participates in lookout duties and chasing rust spots with paint. The galley crew maintains the morale with 3 square meals daily. Knowing we are close to our destination, the mountains of Southern California finally come into view. A timed arrival and the first landing at Vandenberg Air Force Base commenced at morning break of first light. The first CBC Delta rocket was offloaded with an associated second stage container. The ship can only stay in this small harbor for a window of usually 3 to 4 hours. This is due to tide height constraints and available water to float the ship safely. With more cargo to offload, the vessel anchors nearby east of Government Point to wait for the next available window for an acceptable tide cycle. The second docking at Vandenberg shows the second CBC Delta rocket was offloaded with a fairing section. At this point, in viewing the final delivery of the rocket components, the crew of the rocket ship breathes a sigh of relief knowing the safe delivery and the critical mission is now complete.
That dock at Vandenberg was built to offload external tanks. That's why it's so wide. It was built to offload external tanks for the shuttle program, for the shuttle launch, for the DoD shuttle launches going out of Slick 6, but that never happened. It only happened once. Whatever. But yeah, that guy. That guy hasn't lived in Massachusetts for a long time, but I know that accent. I grew up with that accent. Did you hear that? Office building. That's the sound of my people.
Discovery, go at throttle up.
I'm not saying it, you say it. Phil, 69-month resub. Nice. So John, that guy actually posts on Twitter a lot. That's how I knew that rocket ship was in dry dock, believe it or not. Let me see if I can go find it. I'm looking for it now. Give me a moment. I still have the audio unmuted, dude, so if we hear an update, I'll give you an update. Tori Bruno said, this is the CEO. He posted on X. He said it's transient on a redundant data system. Automated hold, checking it and recycling. Sounds like the same problem that they had initially with the data loss. So something's funky with the data transmission systems on this Vulcan right now. That I'm not gonna lie to you. Well, one, I don't know anything about that, to be honest with you. Two, that sounds like something that might take a second to figure out. You got a transient on a data rack, on a data transmission rack, I should say. That's not ideal. Yeah, here, check this out. So yeah, see. Their rocket ship is actually in dry dock right now, which is super.
This is Vulcan Mission Control
cool.
at T-minus 7 minutes and holding. As we await a new T0, let's check back in with Arlena Moses to get another weather update.
Thank you, Edra. Taking a look at radar here this morning, we've had a few more showers develop here across the Gulf Stream, which is located about 20 miles offshore, but they continue to be low enough topped that we're not expecting any significant launch weather concerns. Though, as we continue to push into the window, they will approach the coast. Generally, when we get within 10 nautical miles, which is that white circle that we look at, we have to see them get a little colder topped. A little taller tops, usually about in the 15, maybe 20,000 foot range. And right now, they're kind of below that, so not continuing to be a launch weather concern. So if we go to our forecast, still looking pretty similar for what we were seeing earlier this morning. Overall probability of violations, very low, 5%. Continuing with our breezy easterly winds with temperatures in the low 80s and no significant launch weather concerns. Back to you, Andrea.
$7:19 for sunrise for you. Goalie, I'll be right back. I want to look outside. The sun's already up here, dude. I'm way more north and way more east than you. Let me just check. I'll be right back.
LC on 1, AC.
Sun's out, plants are watered.
I have a recommendation for you for R11 line item adjustment.
Proceed.
Okay, we want to take the following 8 line items from a value of 31.1 to 32. These line items are 188, 191, 194, 197, 207, 210, 213, 216.
Right, I copy line items 188, 191, 194, 197, 207, 210, 213, and 216. All those are currently set to a value of 31.1. The new value of 32 is the direction.
Affirmative.
RLM, LC?
I don't know what any of that means.
RLM, go.
And did you copy the recommendation from the team?
Yes, I did, and ready to implement.
Roger, please put that in work and report when complete.
Copy.
Yeah, that last guy was awfully loud. Pretty. Yeah, dude. I'm telling you, the sky in Florida, you see all kinds of pretty colors, man. Look at that. It's beautiful. Like, you can say whatever you want about Florida, but that... it never got old waking up and seeing that every day. I mean, I lived about 50 miles east of here. Or west of here. 50 miles east is in the ocean. Haven't slept in, like, a day. Give me a break. I lived in Orlando, so it wasn't... I mean, I could see the rocket launches from my back porch. Shouldn't have left. Anyway, moving on. Yeah, it's, the sky is all kinds of pretty colors, man. Sunset and sunrise is just... Timer's back at 7 minutes. They're having some problems with transient data streams on a control board. Or no, transient on a redundant data system. Automated hold. Yeah, well, I'm bad. What are you going to do? Just drive my truck to Florida when I feel like it. You know what I'm saying? It's kind of the same thing. Now you get to see the Boston Bruins, dude. They played yesterday. I don't know if they won or not.
This is Vulcan Mission Control at T-minus 7 minutes and holding. As we look at this beautiful sunrise over Slick 41, we continue to wait on a new T0. Reminder that our launch window today extends to 9 a.m. Eastern. The team continues to work on a new T0, which we will share with you when it becomes available.
Nice, Velk. Yeah, me too, Tip. Yeah. That's what you call that. Yeah. What stage is fueling at? They're in the top off cycle, Slappy. They're good to go.
LCRLM.
Go.
Limits changed on 8 requested line items to upper from 31.1 to 32.0.
Roger.
They're changing parameters on nominal windows for certain things on the rocket, but I don't know what those things are. I already had I still have some coffee left. Hell yeah. Forgot about that. Too conservative limits. That's what it sounds like, Dragoon, but they're flying the Cert-1 flight. They're flying the Cert-1 flight trajectory for the most part, per their own words. So I don't know what would be different this time, but what was that single stage space plane the U.S. is developing? I don't know. There's a lot of different ones, Jens. You need one of those powered coffee cups to keep your coffee warm. I have a Mr. Coffee coffee heater on my desk. I'm not kidding. Where's this rocket going? To space, dude. No, this is a CERT mission. It's just going, on the CERT-1, a similar trajectory to CERT-1, which is somewhere a high orbit insertion. I forget exactly where. It's going nowhere right now. It's going up. No, O10. You need to fix a coffee cup. I wonder if they make those. Morning, EJ. What's up, loading? Where are you going? Frickin' nowhere. Frickin' wham. You going nowhere. They do? All right, Mike. Let's go. What coffee warmer was it? Mr. Coffee? Yeah, I'll see if I can get you a picture.
LCM1 AC.
Go.
Ready to provide you a recommendation.
LD net 1.
Okay.
LD. Proceed AC.
Okay, the team has reviewed the hold that was put into place and isolated that to the VCU line items. We have adjusted the 8 line items affected by this voltage concern. We have no other concerns with proceeding and are recommending another attempt.
Dude, I said undervolting.
LC concurs. LD.
I said undervolting.
LD concurs.
I said it. I said undervolting when they first lost data stream.
Go ahead, LD.
LC, let's please coordinate and implement a new T0 of 11:25:00 Zulu.
Roger. RC, LC net 1.
RC, go ahead.
Please coordinate a new T0 of 11:25:00 Zulu.
Roger.
ALC, please set the countdown clock for a new T0 of 11:25:00
25 minutes out.
Zulu.
Roger, and work.
Okay.
And all personnel on net 1, this is the LC. We're going to reestablish an L25 configuration and proceed again toward another terminal count run. Painting 2, LC.
Good.
Initiate CUC airborne pre-chill.
Roger.
LC, RC.
Go.
The range has approved our new T0 of 11:25 Zulu.
Roger.
And LC, ALC, countdown clock has been set for new T0 of 11:25. We're currently at L25 and counting.
Roger. LOX 2, LC.
LOX 2.
Perform Centaur LO2 fill and drain valve cycle test.
Roger.
Fuel 2, LC.
Go ahead.
Perform Centaur LH2 fill and drain valve cycle test.
Roger.
Has gas established scan pattern 62 and 63.
Roger.
When you undervolt so hard, your rocket almost scrubs.
This is Vulcan Mission Control at T-minus 7 minutes and holding. As you just heard, a new T0 has been established at 7:25 a.m. Eastern.
I'm sorry. I'm sorry.
minus 24 minutes.
Okay. So it sounds like some of the Tori Bruno said it was a redundant data system. It sounded like they had some undervoltage on a data system, on a data streaming system. So their telemetry undervolted, meaning it's not getting the power that it needs. We're about an hour into the window, Havocs. Yep. See undervolt till my rocket scrubs. So stupid, man. The brain rot is real. Scooby-Doo toilet ligma. Or whatever the kids say. I don't know. Scooby-Doo toilet. Don't they have sensors on voltages? Yeah, that's why the rocket stopped. Because undervolting your telemetry is not... Undervolting your data streams is probably not a good idea. Scrappy poo! Yeah, yeah. We're fine. It's not, as long as it's not a main bus B undervolt. Ecom. Try SCE to auxiliary.
Roger. Resume Centaur LO2 topping at flight level.
Roger.
This is Vulcan Mission Control at T-minus 7 minutes and holding. ULA also launches Atlas rockets here in Cape Canaveral, Florida. Let's take a look around.
I'm not sure if it's the same one, Shadow Man. Maybe. Before...
With spacecraft launched to every...
what happened before with this was a what's called a rack integrated controller, or RIC for short. Hey, Starliner. The RIC in triple redundancy. There's 3 of them inside of that building right there. Hey, rocket ship. And it seemed to, yeah, they seem to have some undervoltage problems there. I'm not sure if it's the same component, but we'll see. Who let the overclocker anywhere near the rocket? I don't know.
Canaveral, the team offloads and transports
nice
the rocket
Peterbilt.
to the pad.
You see that Peterbilt, man? Not that
Launch
thing.
site
Screw that thing.
processing begins with Launch Vehicle on Stand, or LVOS. The 107-foot Atlas V boosters and 109-foot Vulcan boosters are transported and hoisted into a vertical position using a crane. Atlas is lifted onto the mobile launch platform, while Vulcan is lifted onto the Vulcan launch platform.
Yep. They have one integration building right now.
With the boosters in place on the launch platforms, solid rocket...
They have one integration building right now, the VIF. So this is the VIF-G right here. That's its tentative name for ULA's ConOps. That one thing can make Atlas and Vulcan rockets and stack them on their launcher. And then one pad can launch Atlas and Vulcan as well. If you notice, there's a track that goes past the VIF, south of it, to the SPOC, Spaceflight Operations and Processing. I think they're building another. They're actually extending the roof on the SPOC, which is another building that's down the train tracks that way. That will be able. They're building another vehicle integration facility that will also be able to make Vulcan and Atlas. That one is called the VIF-C. VIF-G is Vehicle Integration Facility for Government, and VIF-C is the Vehicle Integration Facility for Commercial. So any commercial ULA launches, they're actually building another integration facility to build rockets, which is super cool. A big expansion of facilities for ULA. It's pretty rad. ULA on Slick 41 utilize a clean pad design, meaning they could just move different mobile launchers. There's an ML for Atlas, and there's an ML for Vulcan, and you can launch either one. This pad right now has a Vulcan VC2S on it right there. This is the same launch pad that launched Butch and Sonny on Starliner on the CFT-1 mission with an N-22 Atlas V, completely different vehicle. Which is, I think that's super cool. See the launcher? The launcher is on those pegs right there. They just drive a train underneath it. The train will just lift it up and move it. Which is, I think that's super cool, to be honest. One pad can launch 2 completely different types of vehicles. That shows you the benefits of what's called a clean pad design. 39A at once upon a time, and 39B for NASA were built for this exact purpose. So you could launch whatever you want off of there. You just got to bring a new mobile launcher out. And hopefully it doesn't cost $3 billion. He's joke. Why you have to be mad? What's that, Havix? What you linking me, boy? What you linking me, boy? Yeah, I've seen this. Somebody's linked that before. What kind of train? They're using Trackmobile's Snake, which is a little bit lame, in my opinion. But, it works. Here. This is part of the former Titan ITL, Integrate, Transfer, and Launch complexes. Slick 40 and Slick 41 were part of the Titan ITL. And here, give me 1 second. Let me show you what they used to pull these things with. If you're a train nutter, you'll appreciate this. Oh yeah, baby. Some electromotive diesel switchers. Anyone? Who's the train nerd? Who's the train nerd? 2 EMD switchers. That's pretty dope. EMD switchers. Pretty good design. Pretty damn good. Really wish they still use those. But Trackmobiles are good too, I suppose. I want to see a big boy pulling a rocket. Vargon, I like you. I knew I liked you. I knew I liked you. Those are electromotive diesel switchers. EMD is they're a locomotive manufacturer. They're still around, but at the time when they made those things, they were General Motors. General Motors Electromotive Division. So they're Chevys, but they're good switchers. EMD makes pretty damn good locomotives. Oh, nice. Goalie, thank you very much. You guys want a shot of the VIF-C? Take a look. ULA is extending the roof. They are raising the roof. Yep. That's the Spacecraft Processing and Operations Center, SPOC for short. I actually got the acronym right that time. And yeah, that's down the road from the pad, and they're extending the roof so they can make it into another integration facility, which is super cool. That's super hardcore. Do you know there's an Easter egg in Satisfactory for you to have steam engines?
L minus 16 minutes.
Did you know that L is minus 16 minutes, Cats? I didn't know that, for what it's worth. Steam engines? The door will be extended as well. Yeah, they need to be able to get that in there, so they got to extend the door.
This is Vulcan Mission
eventually.
Control at T-minus 7 minutes and holding. As we move toward a target T0 of 7:25 a.m. Eastern for Cert-2, earlier this year we launched the inaugural flight of the Vulcan rocket. Let's take a look back on that spectacular flight.
Yes, let's. Sunday. Base drop.
Status check. Proceed with terminal count. Vulcan systems propulsion.
Go.
Hydraulics.
Go.
Base drop.
LNG. Go. LO2.
Go.
Water.
Hit the base drop.
Go. Matters. Go. LO2. Go. LH2.
Go.
Pass gas.
Base. Hit me with the base drop.
Go. Range coordinator.
Clear to proceed.
You have permission to launch.
We have ignition.
Yeet! That's pretty good, man. Pretty
and
sweet.
liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in space.
What time is it where I'm at? It is 07:11 right now. So 7:11 a.m. in the morning. Launch is targeting 7:25 right now. It is extremely early for your boy. I like the buttery biscuit base. Base knowledge. Crunchy. The buttery biscuit. Dude, I love that song. Hard, soft. Base. Hey, Achko, what's up, dude? It is 4:11 Pacific. That sucks for you. I love the battery biscuit base. Base knowledge.
We have Vulcan Center separation.
That's a great song, dude.
Looking good. Ignition, full thrust. Both engines are up and running. Cut off.
It's pretty good shot. Hard, soft, battery biscuit base.
LC prop 1.
The base.
Go.
G&G snapper bird cycle test complete.
Roger.
Oh yeah, MP. That dude. Yeah, the buttery biscuit base. That's a great song. That's old school, but still oldie but a goodie. Still goes pretty hard. I'm up this early every day. Why?
All minus 13 minutes.
13 minutes.
Flight control, perform launch on time verification.
Roger.
OSM, place SRB ignition SNA switch in the enable position.
SRB ignition enable.
Verify the FCO, ROC, and OSM hold fire switches are in the proceed position.
Ready to proceed.
RC, verify solar radiation acceptable for launch.
Verified.
PNE-1, verify post-liftoff launch head umbilical purges configured for launch.
Verified.
Launch on time verified.
Roger.
I mean, guys, my day doesn't start till 9 o'clock. That's when I wake up. I usually wake up at 9, but I go to bed at like 2, 3 in the morning. You go to the gymnasium early. You like being the only one there. See, you do that, Junie. I go to the grocery store in the morning. You go to the grocery store.
Terminal count briefing.
9 a.m. No one's there.
It's dope. After the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. RLM, verify red line monitor and event table in the correct configuration for terminal count.
Alto Cert-1 was a translunar injection for the Peregrine lander. So yeah, they were a little ways away.
LC fuel 2.
Go.
Centaur LH2 at flight level.
Roger. LC switch is ready. All steps are complete prior to the status check.
Out minus 11 minutes.
Yeah, of course, O10, because it was towing a Titan 4.
We remain in the hold as we continue towards liftoff.
About 10 minutes,
In a few moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the count. 29 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling.
Status check to proceed with terminal count, Vulcan systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
Chat.
LNG.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
CCQ.
Go.
Op support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Go.
Launch director.
You have permission to launch.
Proceeding with the count.
All right.
ALC, verify T0 is set for 112500 Zulu.
Verified.
ABE, issue MRTU sync pulse.
Roger.
Secure transmitter battery heater and transfer battery internal.
Polling is complete and the team is go for launch. From T-minus 7 minutes until liftoff, you'll hear Dylan Rice and the team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur and arming the flight termination system. At T-minus 1 minute, the Range Operations Commander confirms the range is in a green condition for launch. At T-minus 25 seconds, you'll hear Go Vulcan, Go Centaur, Go Cert-2. This is the final status check of the rocket and payload readiness. At T-minus 6 seconds, initiation of the launch pad water deluge system occurs. At T-minus 3 seconds, the main engines ignite. Then after seeing Vulcan lift off from Slick 41, you'll begin hearing flight commentator Hannah Peters providing launch vehicle ascent data.
They should be releasing the hold here in the next 30 seconds. They're targeting 25 past the hour. 7-minute hold. We're at 18 past the hour. Release hold should be happening momentarily. They are lightning towers around the pad, Bob. Florida's the lightning capital of the world.
On my mark, the time will be T-minus 7 minutes and counting.
Here we go.
3, 2, 1, mark.
Okay.
6:55.
Ground pyros enabled.
The countdown clock is resumed
hi, Mark.
and we are go for launch at 7:25 a.m. Eastern.
Yeah, there's a lot of charges in the clouds. In Florida, all the pads need lightning protection. You don't want lightning hitting that. There's a lot of things that go boom, and electricity combined with the right fueling makes things go boom. Yeah, that's why there's lightning towers there. It's called a lightning arrestor, actually, if you really want to know. Apollo 12 moment. Yeah, exactly. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. The other thing I'm going to do, guys, is run ads so there's no pre-roll. No pre-roll ads on during launch, so you can get, if you're not a sub, you can get the whole vehicle ascent without ads. So we're going to run them. See you on the other side.
This is Vulcan Mission Control at T-minus 5 minutes and 27 seconds. As a reminder, following liftoff, viewers watching in Florida may be able to see Vulcan in flight as it heads east. To get a closer look at this map, check out @ULA Launch on social media.
And just the encoder. Their encoder, Ben. Had some trouble there for a second. My encoder is fine.
4:59.
Inside of 5 minutes.
Vulcan LNG. Securing Vulcan LO2.
Okay. We'll see, Wiz. Who knows? T-minus 4 minutes, 20 seconds. This would be the third time, Velk. We'll see what happens.
4:10.
Foliage conditioning complete.
Okay. You're going to see that second hydrogen flare stack turn on here in a moment. Note that
this is space. I'm in space.
See? Second hydrogen stack is on. And then the GOX vent on the first stage is closed. Predominant gift of the sub to Burton. I'm not saying the first part of that, man. Don't need any bad juju. Hey, Ellisers, what's up, dude? What the heck was... They were changing they changed the ISO on that camera. You see that? Hey, Hert, what's going on?
Hydraulics at pre-launch.
500 bits. Thank you very much.
Discovery, go at throttle up.
The Swamper, 2 months. Thanks, buddy. T-minus 3 minutes. Got bright really fast. Yeah, it did.
249. FTS internal.
Flight termination system
Discovery,
is on internal power. Hey, Sikar.
238.
What's going on, buddy? Welcome to Mission Control. You go at throttle up momentarily, though. Not right now.
Kilo 2 POP started.
I don't know what that meant. I've never heard that before. It's going straight east. It's going straight east, Thumper. Hey, monkeys.
T-minus 2 minutes. The launch
59.
vehicle, ground systems, and eastern range are go for launch. For those of you who are just joining us, I'm Andrea Linhoff, your host for today's live coverage of ULA's second Vulcan rocket launch. At this time, the team is not working any issues, and we're proceeding towards a liftoff time at 7:25 a.m. Eastern.
She blinked that time.
135. FTSR.
T-minus 90 seconds. Flight termination system is armed.
$120.
She's an engineer, Bob. What do you want?
115.
ECS, reduce ECS for launch.
Environmental control systems are ECS. A little bit of ice off the vehicle there.
T-minus 1 minute.
60 seconds.
Report range status.
Range green.
Range operations coordinator reports range green. That's basically the air traffic control, quote unquote.
45.
Vulcan tanks at step 3.
40 seconds.
$30.
BE4 start box go.
28.
Verify ECS reduced for launch.
Environmental
Verified.
control systems are reduced.
Status check.
Go Vulcan.
Go Centaur.
Go Cert-2.
15.
15.
T-minus 10, 9, 8, 7, 6,
That delusion
5,
turn on here.
4, 3.
Ignition.
We have engine ignition. 1.
Boom. Send it.
And liftoff of
Cert-2's
the
in the
United
air.
Launch Alliance Vulcan rocket, carrying ULA's
Look real
legacy
good.
of reliability, orbital accuracy, and high energy performance.
We got a flight early Friday morning.
Everything looking up. BE4 performing as expected. All temperatures and pressures looking good. Vehicle has begun its pitch and raw program.
Yeah, I saw it, Phil. Yeah. Did you see the the thermal protection blankets on the BE4s inflated for a second before ignition? A lot of ice
You
coming
are
off
hearing
that thing.
Hannah Peters providing launch vehicle ascent data.
Oh yeah. What a looker.
And we've ended the pitch program. Vulcan's now at 1.5 or 0.5 Mach.
Yeah, it did the pitch over like Cert 1. There's some... I don't remember all that stuff coming off of it before, but it could be ice. Shifty!
Vehicle is past Mach 1. Vulcan
That
is
left
supersonic,
booster,
and
the left
maximum dynamic pressure.
GM63.
Coming up on SRB burnout.
The flames on the left booster are... oh,
and we
crap!
have indication of SRB burnout. Up next is SRB jettison.
Stay together. Stay together! That's not... oh, balls. Stay together. The nozzle popped. The nozzle popped. That was nozzle coming off of it. Look at the flame. See the flame on the right SRB is bigger than the one on the left? Not great.
Body rates continue to look nominal.
That GM63 nozzle popped. Notice how it flamed out before the other one. Yeah, that's not good. The casing just delaminated. That's really bad. That's not great. I think the ascent will be okay, but...
Vulcan is 19 miles in altitude.
We just heard confirmation of solid rocket booster jettison. We have about 3 minutes until we reach our next mission event, boosters engine cutoff.
Oh, that's gonna screw with the trajectory pretty bad, guys. The casing just delaminated. That's not good.
Up on RCS valve activation.
Yeah. Oh, okay. Like, I'm 100% sure that that's what happened. That they lost the nozzle. It looks like the vehicle's okay, but Katra, I can tell you right now that trajectory is screwed.
And we're now just about 2 minutes to nominal BECO.
It's gonna compensate for it.
And we've had RCS
see,
valve
look
activation.
at the pitch up. Come on, baby, make it, baby. Oh, not. That does not look good.
Look good. BE4s are performing as expected.
Are you
Body
sure?
rates are trending towards 0.
It's trying to compensate. That's what it's trying to do. It's compensating by burning radial out. See,
down
look.
The range track.
See, look. It's going that way, but the rocket's pitched that way. Oh, baby, stay together, please. It's compensating. It was compensating for the SRB, the guidance systems. Yeah, Phil, that's bad. That booster, that GM63 quit. It quit about
Continue to have 2 good
2/3
engines.
of the way
Body
up.
rates trending towards 0. And we're now about 1 minute to nominal BECO.
That's not good, guys. Yeah, that's bad.
Vulcan is now 1/4 of its liftoff weight.
I don't even know if it makes it port, if it's going to pass.
And Vulcan is now passing the Kármán line.
Yeah, they lost the nozzle casing, Ben. They lost casing. The booster, that GM63 delaminated itself. Not good.
And we started boost phase chill down on the second stage engine.
Thank God Dream Chaser isn't on board. Bro.
And the BE4s are throttling to maintain a constant acceleration.
Guys, they might be able to pull this one out because there's no payload on board. They might be able to pull this one out because the guidance systems are clearly compensating.
And we've concluded our boost phase chill down. And PU has gone to open loop. And we have BECO, booster engine cutoff.
Okay.
And we have Vulcan Centaur separation. And pre-start on LH2 and LO2. And we have full thrust on the RL-10. And bearing jettison has been indicated.
Come on, Centaur 5, do your thing.
And we've begun thermal loop conditioning on the RCS. And fixed angles on Centaur PU. Vehicle is now 123 miles in altitude, 345 miles downrange, and traveling at 10,000 miles per hour.
Look at that. They saw it. Hands on face. Dead giveaway. Every time, dude. Every time. You see someone doing this, something's wrong.
And we're getting indications that booster performance was within expectations.
Yeah, about that.
RL-10 continues to perform nominally.
Well, Tessa, there's nothing they can do. The vehicle's flying on a predetermined trajectory. You better hope your GNC was good enough to your GNC systems are good enough to compensate. Note how they're not showing live data this time. That, I'm telling you, the loss of thrust is going to screw the TWR. That's going to make Centaur do a lot more work. And the guidance systems did compensate by doing a radial outburn after the SRBs separated. Right now, there's really nothing you could do. It's just hope that the GNC compensated and that it'll be able to still try and get that orbit. Once again, because they have no payload on board, it might be able to compensate. It's going to be close. But that's not good. That's not good. What happened is not great. That's really bad.
Sure. So I think it was a beautiful liftoff this morning. I think we're all really excited to see that. It's such a significant launch in terms of our certification.
She's still burning
where
radial
we're
out.
Going with Vulcan, so it was
just a goalie. The nozzle delaminated. They lost the throat on the right side, the right hand GM63. I saw it right away.
Our suppliers across the country. So many people put in so much hard work.
All right, screw this. Hold on.
Dedication into this, and it's a.
I want to go back. I want to see the ignition, if you guys don't mind.
There's so many different parts that go into a successful, even just getting off the pad.
Absolutely, yeah.
Just real quick. Watch it. With that shot, it'll be the SRB that's further away. What could have caused it? I don't know. It's this SRB. So guys, from here down, they lost it. You can have that from a casing crack. That could you could get nozzle burned through if the nozzle wasn't manufactured correctly. You got to watch this thing over here. Anything weird happen during ignition? Nope, it looked fine. But yeah, that nozzle destroyed itself. It's bad. Let's go back to live. I just wanted to see it real quick.
Talked a lot during the broadcast.
United Launch Alliance.
Important for certification this launch today and our government customers. Why don't you tell us a little bit about
that?
Ben.
Sure, I'm wondering if the NSF footage caught it. They had nozzle burned through. That's really bad. That means that the nozzle wasn't manufactured correctly. Guys, even if this mission makes it, no. The Department of Defense won't trust you to launch stuff if your SRBs are delaminating themselves. They got nozzle burned through. That's really bad. That is really bad. That's what screwed Vega C. The Zafiro 40, their second stage on the ESA's Vega C rocket, did that. It did that same thing. Bacon Warrior, 33 months. Did that SRB look slightly off angle, or is it just perspective? Max, if I saw that right, let me go take a look. If I saw that right directly after liftoff, so take a look, man. It might just be the camera. I mean, the nozzles are canted out. They are canted out on these GM63s. But look where the fire is coming from. It's coming from the sides. That's not great. That's not great. That's like complete nozzle failure. That's really bad. Do you think maybe ice hit it? It's possible. It's possible. See, I saw this ice coming off, and I'm like, okay, that's the ice coming off. And then I started to see stuff that wasn't ice. I said it may have been ice, but so you get up here, and eventually all the ice comes off, right? But right there, I saw it. Nozzle failure. Look at the perturbations in the plume. See that? Right there, it popped. The nozzle popped right there. Yeah, I didn't see it. I didn't catch it the first time. Yeah, that's bad. That's complete nozzle failure. Yeah. Good thing the casing didn't fully go, but I didn't see it the first time. Yeah, see, look, flames are coming out the sides of that nozzle. That's bad. That's really bad. Like I said, they might be able to pull it out because they're second stage, because there's no payload. If there was payload on this, they'd be boned. Watch. Right there. See? Right there. See the difference? Yeah, yeah. Nozzle failure. Not good. Let's go back up to live. They're still showing PR footage. NSF feeds show the nozzle coming off. Dude, it came off.
We're in this together. I'm really looking forward.
Is this a clip from NSF, dude? Hang on.
We're going to get the data to the customer, help them wrap up any loose items they have.
All temperatures and pressures look good. Vehicle has begun its pitch and drop program.
That's bad.
So following up a little bit about what Greg is saying, why don't you tell us a little bit about how
temperatures
ULA
and
has
pressures
been working with the Space Force to certify.
Vehicle has begun its pitch and drop program.
Yeah, that's bad.
Shoulder to shoulder throughout the entire design, development, test, build, and now operations
Guys,
for Vulcan with the Space Force.
I don't think I need to say this.
Throughout that process, and we continue to provide information.
That footage, so first of all, that footage is coming from our buddies over at NSF. That was just a clip. They're live streaming this too. If the flames are coming out the side, you got a big problem. Like a big problem.
So, you know, you work with the Space Force pretty regularly, obviously.
Yes.
But what's next for
Centaur is going
to
to pull it out because they have no payload.
How is Vulcan a difference maker for the Space Force?
Sure. So once we get certification completed, that will allow us to be able to launch
This is from the
national
NSF
security space
feed.
missions that we have on contract. So we have some, you know, that we're getting close to being ready to launch, and we're really excited to focus on those and the mission success for those missions.
That's the whole nozzle.
And
The
Vulcan
whole,
really,
the whole nozzle. The whole
was
nozzle
designed
came
to
off.
meet the
That's
entire range of the
extraordinary.
national security space requirements. So it has the Centaur.
Guys, they dodged a freaking bullet. I'm not trying to over dramatize this. You dodged a bullet. If that thing hit the B4, you would have been screwed. Like completely screwed. That's like I said, even if Centaur makes it, I don't think I would not give a. If I was the Air Force or the Space Force right now, you wouldn't be getting a cert. Your nozzle came off during ascent. That's extremely bad.
Vulcan and the Space Force.
Me too.
Thank you so much for joining us, Megan.
Thanks,
I'll let you
Andrea.
get back to console.
All right.
Thank you so much.
Thanks.
Think you cracked on the pad? I didn't see anything weird happening at ignition, dude.
Just about 2 minutes to MECO, or to nominal MECO. Everything continues to perform nominally. The vehicle is now traveling at 14,500 miles per hour.
Dr. WD-40, thank you for the raid. Yeah, this is a long ascent. I wish we had some telemetry. I'd be able to tell you. It looks like the guidance systems on Centaur compensated,
And we're
but
now
once again,
approaching
it compensated.
approximately 1 minute to nominal MECO.
It only compensated here because there's no payload on board, guys. They got lucky. That they dodged a bullet there. Like, that's no good. If that had happened with a spy satellite or anything, if that had happened with Dream Chaser on board, Dream Chaser ain't coming back. They wouldn't have been able to get into space with that. That's how big, that's how much of a difference that SRM makes. She said 14.5K with 2 minutes to MECO.
Discovery, go at throttle up.
And
Username
has come off its lock stop.
52 months.
This
Thanks,
is
buddy.
Vulcan mission control at T plus 15 minutes and 35 seconds. We're approaching the first main engine cutoff. Let's listen in.
Car is now orbital. NPU has gone to open loop.
Dream
Coming up on
Chaser is
MECO.
Dream Chaser is a small space shuttle, Alto. It's a little resupply space shuttle for the space station. 15:55 is the scheduled MECO time.
And we have MECO, main engine cutoff 1.
Yeah. It compensated. You lucky,
This is Vulcan Mission Control at T
melon
plus
farmers.
16 minutes and 22 seconds. We just heard flight commentator Hannah Peters confirm the successful cutoff of the main engine and all systems continue to operate nominally. Our next mission event, main engine start, will occur in about 15 minutes. While we wait, let's hear more about the Vulcan rocket from Mark Peller, ULA's Senior Vice President of Vulcan Development and Advanced Programs.
Cert-2 is the final step in formal certification of the Vulcan rocket. After launch today, we'll take the time to go through the data,
maybe
verify the system's
I don't know,
performance,
Creeper, maybe.
and move on with our government customer to complete the formal certification. And the real exciting part for me is really turning the corner and getting to start to perform those missions. I know we have a really busy manifest with some extremely important missions for this nation, and I'm just so excited to have the opportunity to support those and really start to realize the promise of Vulcan and everything that we've worked so hard on for the last 10 years and the capabilities that it will bring and the missions that it will support for our country. This is the start of a new era with Vulcan. We're very excited to turn this corner and move into the operational phase of the Vulcan program.
That's bad.
Vulcan right now is capable of launching a variety of missions, from low Earth orbit to direct inject to geostationary orbit.
Guys, the nozzle completely delaminated.
To launch into the moon or elsewhere in our solar system. Certification implies it's determined to be.
I don't think I can stress how lucky this rocket is to be in space. Usually when SRBs decide to not be SRBs anymore, it doesn't end well. Like, I can think of several examples prior where SRBs doing that has ended extraordinarily bad. That is, dude. Oh no. No, they're GEM-63s. Aerojet Rocketdyne makes them. They pull the Kerbal. Dude, parts falling off of it is not... Like, I don't mean to disparage ULA, but that's not good. It's really bad. That sucks. Yeah, the freaking nozzle came off. I can't believe it compensated, dude. Tory Bruno needs to pay his guidance, navigation, and control guys. Whoever they are, give them a friggin' raise, dude. Give them a freaking raise. GEM-63 is Northrop Grumman? Is it? The guidance system compensated for the SRB blowing off the side of the vehicle. That's nuts, man. Suboptimal. Yeah, I saw it. Yeah, that's... They're just showing promo footage. Jared Locke yeah, see? Casing's gone. Or not the casing, that's the casing. The nozzle is gone. So what happens when the nozzle pops, all right? If you're gonna get nozzle burned through like that, right? So what is an SRB? We can talk into it for a second here. I'll keep their cast up just in case. Look at his second photograph. I don't, yeah, it's bad. An SRB is essentially a big steel pipe, guys. It's a big steel pipe with a constriction or a gas impingement at the end. That gas impingement is the throat. So the entire pipe is your combustion chamber, okay? Now, what happens is the solid fuel ignites and it shoots gas through the impingement. That's what you want. That's when it's working correctly. if you lose that impingement, basically you'll burn out the propellant extraordinarily fast, right? Because all of it's just going to shoot out all at once, right? That impingement is kind of keeping the pressure inside of the booster, so the booster inside of that SRM, right? The throat is basically holding the pressure inside of it, and if you get rid of it, all the pressure comes out all at once, which is why we saw a big explosion when it happened. You're basically going to completely lose your thrust. Yeah, and the SRB will almost instantly burn out. You'll have what's called a shorter burn time. The burn time on those things are 90 seconds, if I'm remembering right. And that thing got nowhere near that. Now, guys, it compensated, right? But losing thrust on that SRB is bad. That's really bad because that's 2,000 kilonewtons of thrust here. Each one of those GEM 63XLs produces about 2 meganewtons of thrust, and each BE4 is 2.4 meganewtons. So we're talking about losing a quarter of your thrust at that point during ascent, which is very bad. I can't believe it compensated. Guys, the only reason that rocket made it into space is because it had no payload. If this had a payload on board, it wouldn't have made it. It would, like 100% sure, it would not have made it. Goalie, you got a picture for me? Look at NG's link. NSF has, did D take a slow-mo? Yeah, hold on. I want to see Goalie's pictures. Yeah, see? I saw that, and I'm like, that doesn't look like ice, but I don't remember seeing this before on the other Vulcan launch, but I could be misremembering. And then I saw it again. Yeah, that's bad. See how one of them has a lot of happy dust coming out of it, and the other one doesn't? That's not great. Good pictures, Goalie. Yeah, see, these are pieces of the nozzle, what's left of it, ablating off. The nozzle is also your thermal control system because it's using an ablator nozzle. You lose the nozzle completely. That heat has to go somewhere, and it's melting other parts of the SRB. And once again, this is not speculation. I know exactly what happened there. That I'm 100% sure. We've seen this before. This did a Zafiro 40. I actually just did a Space News the other day talking about this exact thing. Because the Zafiro 40 on Vega C did that. It delaminated its entire case, like the entire back part of the casing, which is bad. And Vega failed because of it. Baron, you're at Cocoa Beach. We saw the nozzle come off clean and it can be seen falling off. That's why I wasn't spamming in chat. Yep. Northrop is going to get a very angry phone call. Yeah, it's not Aerojet Rocketdyne, as I said it was Aerojet before. It's not. Northrop Grumman makes those things. That is... Yeah, that's enough to... I'm going to say that they're... Like, this is my gut. This is... EJ's guessing now. I don't think they're going to need another certification mission. There is no reason, unless what happened is well understood, there's no reason they should get that cert. Like, I'm not trying to be a jerk. I love ULA. Like, I would not trust this thing with a spy satellite at this point. Absolutely not. What the hell's Centaur doing?
And Centaur has now begun to despin from its PTC roll in preparation for MES-2.
Main engine start. Where are we? Which coast? This would be Africa, guys. They were looking for, I think they're looking for a 28-degree inclination. So that's like Ghana right there, like over here.
Welcome back. Thank you for following mission progress of ULA's Vulcan Cert-2 flight. If you're just tuning in, I'm Andrea Lenhoff, joining you from ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida.
What is the B
ULA's
force
second
gimbal range?
Vulcan rocket lifted off at 7:25
Apparently good
a.m.
enough,
and all
Phil.
systems continue to operate nominally.
It had
As
to,
we
dude,
continue
it must
in
have done
second
that.
stage flight,
It had
let's
to.
hear from ULA's Director
Your center of thrust
Upgrades
completely
Development, Amanda
changed.
Piketty, about the capability of ULA's venerable Centaur.
Jeez. Yeah, the Centaur just saved your bacon,
Centaur,
dude.
the second stage for ULA's Vulcan rocket, was
Holy
developed in the 1960s and continues to play a vital role in our nation.
Yeah, Vulcan decided it wanted to be an Atlas 411.
Vulcan lifts off with the booster vehicle.
All right, do we have
up into space? We then separate the Centaur second stage where it takes the spacecraft where it needs to go.
here?
Second stage of flight is
Hold on. I'll keep the audio up there. This is coming from Chris.
spacecraft to its final orbit.
This is the slow-mo footage.
Exactly where it
Sunrise lighting.
in the orientation that it wants to be.
And that is the voice of Yak. Oh, that's awful.
Ooh, yeah, that's not.
Dude, there's the nozzle! Holy sh!
The first being that is a pressure stabilized stage.
Ooh, yeah, that's not.
About as thick as a dime. That coupled with the fact that we utilize cryogenic fluids, liquid hydrogen,
Oh no! Yo, that is a certified pucker moment. Dude, that is, oh my god, that's so bad.
The Centaur variant for
Oh no!
notice right off the bat, it is significantly larger.
Look at how it almost veers off course. Dude, I could already tell from the trajectory. Yeah. Here, let's see. What is this? It's so bad.
Only a tiny mass impact from a dry mass.
Holy sh! Dude, you have no idea how close that came to failing. Oh my gosh, they are so lucky. Dude. Oh my gosh. Once again, give your GNC guys a frigging raise. Holy balls, that is so close to exploding. Oh my goodness. Well, the SRB did explode. That's so close to being a complete rud. Like, dude, dodged a freaking bullet. The only reason it made it is because they had no payload. That is a catastrophic failure. This thing does not make it to orbit if they had a payload on board. Like, once again, I hate to disparage ULA. I love ULA. That's so bad. But it's important to remember, new rocket, new boosters. This is only its second flight. You're going to have some teething problems with your launch vehicle. It always happens. Always. Always. But also, there's no way you're getting certified with that happening. I will tell you that right now. There is not a chance in hell that that's happening. Like, that is... Dude, I need to go back to Max and D's footage. Or I think this was just D, but... Dude, the nozzle flies off! Oh, no! Dude, that's the... No, they launched with no payload. They launched with a small mass simulator, Apple, for this flight. They didn't put a payload on board. Hold on.
This is Vulcan Mission Control at T plus 29 minutes and 49 seconds. We're about a minute away from the second main engine start. Let's go back to Hannah Peters.
And we have pre-start on LH2.
Just join. What happened? One of the SRBs, Balaxy, did a Zafiro 40 and decided it wanted to blow the nozzle off completely. Complete SRB loss of chamber pressure on ascent. Almost, dude, Vulcan came like that close to just completely
and LH2
exploding.
Pre-start? Coming up on main engine start 2.
Okay, MES2. Morton Thiokol called.
And we have ignition and full thrust on the RL-10.
Car analogy to what just happened. The SRB did the car equivalent of
And
blowing a
vehicles
head
begun
gasket.
closed loop steering.
This is Vulcan
Yeah.
mission control at
You
T
lost
plus
cooling
31 minutes
and
and
power.
19 and 20 seconds.
Yeah.
We just
Centaur's
heard
fine,
confirmation
though.
of second main engine start. While we wait for engine cutoff, scheduled to occur in about 4 minutes, let's take a look at how our Vulcan booster stage is painted prior to departing ULA's Decatur, Alabama factory.
Yeah, let's look. I'd be particularly interested in how those SRBs are made. No, Tori, yeehaw, this flight, that's how you know. Yeah, he's probably buried in a telemetry computer at this point. So, guys, what can cause that to happen? Casing cracks. Cracks in the casing can cause that problem. Cracks in the casing will cause that problem. You can get microscopic fractures in the casing. See, okay, here's what I mean about this being, it being this close to being an issue, okay? Here. The last time you had a casing crack on a booster on the way up, this happened. Watch, this was a Delta II rocket from 1997. This also had the same problem. It was just a little bit more up the casing on the SRB than ULA. This is what I mean. That was about maybe this far off from this happening. Wait for it. Yeah. That was close. It almost did that. It was that close. That's what happens if the straight casing fails. They had a nozzle failure. But if the crack was just a little bit further up, it would have done that.
This is
Like
Vulcan mission control at T plus 33 minutes and 23 seconds. We're coming up on the second main engine cutoff in just over a minute. Let's listen in.
Vehicle continues to look good in this burn. Engine parameters are as expected. PU is correct.
That's right, Shinar, yeah.
And our body rates are trending towards 0.
How do they scan for casing cracks during the manufacturing process? An X-ray. X-raying. You gotta X-ray the casing. Could be overheating like the Omega nozzle.
Go at throttle up.
The overheating from the Omega nozzle came, Phil, from the nozzle not being a vacuum optimized nozzle that they were firing close
Approximately 1 minute to MECO.
to sea level. So the nozzle expansion ratio wasn't good because it wasn't good for the test stand because the rocket would normally ascend up into an area where that nozzle would be optimized for the pressure. It wasn't optimized on the test stand, and they had flow separation. Non-uniform heating caused cracks in the nozzle, and it caused the nozzle to nozzle int. Caused it to explode. That looked like what happened, but dude, the whole casing popped. Like, there was no casing. That's my alarm. There was no casing on the bottom of that thing when it separated. It was completely gone. It was just a pipe. So I don't think this is nozzle blow through. Something happened in the throat and the bottom of the casing and the throat.
And we have MECO,
Yeah.
main engine cut off too.
Oh.
We're now venting the fuel tank. We have approximately 2 minutes and 49 seconds until simulated spacecraft separation.
Wow.
It's full settling on RCS.
Yeah.
And the vehicle is now rolling to its simulated SB-SEP attitude.
Dude, NSF with the friggin' goods, man. I have permission to look at this, fellas, if you're wondering. But my buddies over at NSF are just magnificent. Dude. Oh. You know what? That's not the nozzle. You know what that is? That's the bottom of the casing. That's the thing that I'm talking about. Completely coming off.
And RCS is now doing 50% settling.
Look at
and
how
thruster
hot
warming.
that thing is. Here, let me show you what piece that is. Let me show you. Hold on. So what you're seeing...
Three. We have engine.
So, okay. What you're seeing, that thing is this. This piece. See this piece? The nozzle's already gone there. That's this piece. That's the bottom of the casing. That indicates that they had a failure at the throat, which is pretty consistent with what we saw. If you have a failure at the throat, you're still going to be able to maintain chamber pressure, but the problem is that this thing won't be able to take all the heat. Why? Because the heat is supposed to be going into an object that has much bigger volume here. That's why the bottom of the casing is glowing completely.
Speaking of heat.
Oh, what is that?
What does it look like?
You made me breakfast?
I wanted bacon and eggs. I'm not going to not make my host bacon and eggs if I want bacon and eggs. What kind of sense does that make?
Yeah, that's fair. Thanks, man.
Yep.
Ernock made breakfast, which is pretty cool. So per this footage, dude, that's the bottom of the casing. Thank you, Ernock. That's this. Actually, it's that casing over there. See this piece right here? It's that. That's bad. Yeah, that's not good. That is the casing completely coming off. Look at how hot it is, because that thing is not enough to keep it
Vehicle's
cool.
now rolling.
That's why it
And
blew
we
off.
are depressurizing the LH2 tank.
Is he a good cook though? I don't know.
And
Let
we
me
have
check real
simulated
quick.
spacecraft separation. We now have an approximately 28-minute coast until the third burn.
Give me a second. I'll be right back.
And vehicle has started its descent and is now pointing towards Cedrus.
It's possible, Katra. Who knows?
Passing 40 minutes into flight, Centaur continues to look good throughout this coast period. All parameters are looking nominal. RCS is performing its periodic firing. And our body rate
Houston, Tranquility Base here. The Eagle has landed.
Because of the SRB failure, could this mean that both Atlas V and Vulcan will be grounded since both use a variant of the GEM 63? Or would it just an investigation into the GEM 63 be required?
Yes. Yes. That is, yeah.
This is Vulcan
I'd look
mission
into it.
control at T
It's-
plus
you don't know how
41
bad
minutes
that
and
is.
50 seconds.
Because Atlas,
We
yeah.
just heard flight commentator
they
Hannah
won't use
Peters
those.
confirm the successful completion of the beginning of today's flight. This completes today's mission coverage. I am now joined by ULA's CEO and President, Tori Bruno. Tori, thank you so much for being here with me today.
My pleasure.
I've worked on this program for a really long time. I'm very excited to see the beautiful launch. I feel like we waited for the perfect moment to lift off. So I just want to say congratulations. It's just an incredible day.
Well, thank you, and you too.
Thank you. And thank you so much for being here. It's my understanding you want to tell us a little bit about today's flight.
Yeah, so the trajectory was nominal throughout. We came to our first insertion on the orbit that we intended, so all of that is good. We did, however, have an observation on SRB number 1, and so we will be off looking into that after the mission is complete. Other than that, the flight was nominal.
And you know, that's the great thing about these certification flights is it allows us to get more information as we get into our regular launch cadence. But, you know, just a testament to Centaur and Booster on how beautiful that launch was so far.
It was a gorgeous liftoff, absolutely.
Great. So as we continue on with this launch, after the launch, we'll go through, look at the data and just make sure that we're certified for, you know, national security space missions. Why don't you tell us a little bit about what that certification means for ULA and the launch industry as a whole?
Yeah, certainly. Well, for ULA, we designed this rocket for the national security mission space. In completing the second certification flight successfully allows us to begin those missions that are urgent and important to the country. What it means overall for the industry is that we've introduced a new launch vehicle and a vehicle that is capable of launching at a pretty high tempo, and so we have broadened the entire country's capability for lift, and you will begin to see that launch tempo really tick up, especially next year.
I'm really looking forward to that. Who doesn't like a rocket launch?
Well, no one, as far as I know.
I know, those people would be crazy. So I do want to say how hard it's been the past couple of years. Everybody has worked to get to this moment. I mean, this is kind of a pinnacle for us in terms of overall Vulcan development. Do you have anything to say to all of the folks that have worked on Vulcan over the years?
Absolutely. I just want to express my appreciation. Developing a new rocket is a monumental task. It is one of the pinnacles of engineering accomplishment. It truly is rocket science. Yeah. Our team has worked so very hard over the last several years to design this rocket, to build it, to test it, to overcome the many technical challenges that are inherent to that. I could not be more proud.
Lila, you ain't wrong.
Thank you all.
Thank you. Seriously.
That was sincere.
This has been just so incredible to be a part of this team. And I don't think that there's anything I've been as proud of, besides my children, of course, to this moment. So now that we've launched, hopefully we'll get certification under our belts here shortly. What's next for Vulcan?
Well, we have a pair of national security missions in the pipeline. So we'll do those, and then we'll roll into next year with a whole number of flights.
Great. It's going to be an exciting year next year, for sure.
Yes, it will.
Well, Tori, I know you have to get back, but thank you so much for joining us today. I am very excited about today's launch, and I always appreciate your time.
Oh, you bet. Thank you. You're doing a great job today.
Thank you so much.
All right.
Bye-bye. Bye-bye.
There is Flame Trench today, and it looks like we got something to talk about. Yeah, Tori was not happy. He was pretty down in the dumps. That guy's super cool for what it's worth. Yeah, he was not happy. Ernock Breakfast is fantastic.
At this time, we'll end our live coverage. For more information about the Vulcan rocket, please visit ulalaunch.com. I'm Andrea Linhoff. Thank you for joining us on this exciting day. Before we sign off, let's take another look at the Vulcan rocket lifting off the pad.
We just got to see if the number 1 SRB does anything weird here.
8, 7,
we
6,
watched it already, folks.
5, 4.
So once again, it failed right there. That right at the throat. This whole thing popped off, and then D's footage from NSF showed the back of the casing coming off, which is you don't know how close that is to being really bad. They got lucky. That was dodging a bullet there. Oh yeah.
4, 3. We have engine ignition. 1. And liftoff of the United Launch Alliance Vulcan rocket, carrying ULA's legacy of reliability, orbital accuracy, and high energy performance.
Everything looking nominal. BE4 performing as expected. All temperatures.
Yeah, they cut it before it popped. So, yeah, guys, watch the guidance systems compensate. Dude, man, somebody up there likes Tori Bruno. Let me tell you that right now. That's so close to blowing up. Oh my god. Yeah, dude, the whole thing tips. And it's so bad. Okay, why is this a big problem? All right. So why am I freaking out? All right. This is a Guinness bottle. Pretend this is the rocket, okay? Pretend it's the rocket. All right. When you get off vector thrust at this stage during ascent, we're at about T plus 40 seconds here. When that happens, if this thing goes too far, the aerodynamic forces will take it. And there will be a point where your thrust vector control systems won't be able to compensate for the aerodynamic load that's being pushed on the top of the vehicle. Right? The aerodynamic moment of the vehicle at this point is so intense that they have to throttle down the engines usually. If the moment, because the vehicle's tilting to the side like that, gets to be too much, it'll just flip out of control and blow up. That's happened before. It looks like the BE4s compensated for it and dialed it back in. Dude, I'm telling you, any further to the side, this thing is done. It explodes. The rocket is only designed to fly through the atmosphere one way. It's not designed to fly through the atmosphere sideways. Once it starts flying sideways, the aerodynamic forces hitting the side of the vehicle as opposed to the front of the vehicle could cause explosions, let's just say. Yeah, that breaks things because the rocket is only designed to take load on its long axis. If it tries to get load from the side, you're taking compression load and turning it into shearing load, and that's bad. Hang on, Adrian asked me a question. Hang on. I'm linking the NSF boys to this. All right. Hey, Whitney. Whitney, the GM63XL decided it wanted to be a Zafiro today. Watch. Thank you for the raid. Oh. That's like an inch from death. Oh my goodness. Whitney, did you see this footage from NSF? Look at this. Watch this. D caught the entire casing coming off. Look at the aft casing. Oh, that is so bad. Oh. Oh my gosh. If it pops and that casing goes in a different direction, this thing blows up. It's like that close from just done. Who makes the SRBs? Northrop Grumman. Oh, God. That... Too much heat. Sorry, talking to the NSF guys. You think some of Vulcan's programmers just became steely-eyed missile men? Yeah. Yeah, I'm awake now. Yeah, right. Dude. That's so bad. Anybody have any doubt in the BE-4s? 3 seconds after liftoff. Whose picture is this, Baron? Where'd you get this picture from? I gotta give credit where credit is due. Oh my goodness. Yeah. That's what I thought I saw when we watched the replay. It failed right at the throat. You guys, if you're going to link a photo like this, you got to give credit. We need to give credit to the photographers that are out there doing this work, because we don't. You know what I mean? It's from NSF? Okay, cool. If it had failed on the BE-4 side, Vulcan would be at the bottom of the ocean right now. All of it, not part of it. I can't believe that. I can't believe it. Anyway, Whitney, thank you very much for the raid. Merci beaucoup. Appreciate it. That's just... I can't believe this footage from NSF. This is D. D took this footage, and it's... Oh, that's so... Oh, man, I can't watch it. It's so hard to watch, dude. If hypothetically it'd be carrying Starliner or other crew vehicle, do you think the launch escape system would have activated? No, it wouldn't trigger an LES. It would have triggered a probably... I'm thinking. We're 40 seconds in, so that would have been right at max Q. So you're still in mode 1 alpha. Yeah, it's possible, Bill. Yeah, it's possible. Yeah. But Vulcan is not human rated. Not yet, at least. I think it would. Could an SLS shuttle SRB survive this? Goalie, I knew someone was going to ask that question. Why did you ask that question? The last time an SRB casing failed on the space shuttle, it was in 1986. I'm not elaborating anymore. But proceeds to elaborate more. You got to remember, these are a single casing SRBs, all right? It's a single case, so it's basically one big pipe shape. The shuttle and SLS boosters are a segmented booster, meaning you have multiple casings stacked together and sealed with O-rings. The clip at 28 seconds shows its start. That's coming from NSF. We saw... Yeah. What's the T0? What's liftoff in this? It's this casing that failed over here, this guy. I'm not 100% sure if we saw anything at ignition. It's hard to tell from the camera. Watch right there.
Vehicle has begun its pitch and drop program.
Guys, that's the casing. The casing failed. I can't believe that. Goalie, that looks like it failed right right there. Or right here. It looks like it failed at the throat. That is coincidentally the hottest part, one of the hottest parts of the nozzle and the whole engine for that matter. Are they carbon composite? I don't remember, Phil. These ones? Yeah, maybe. But the nozzle is not necessarily carbon composite. The nozzle and the throat on these SRBs are made out of an ablator. Seriously, SRB nozzles are made out of heat shield. You notice that if you look at it right there, it looks like heat shield? Because it is. They need to use that to be able to control the heat that's generated from the SRB. Like right where my mouse cursor is right where it failed. Now, like once again, I'm looking to see if there's anything funky going on there. I don't see anything weird. Hang on. What's that? What are those? Those aren't over here. Sorry, I'm a noob from the raid, but the faulty booster is not the same shape as the one on the right of launch. What do you mean? They're the same. The nozzles are pointed outwards to point through the center of gravity of the vehicle. Guys, that's not... Whatever those things are, they're not supposed to be there. But that, if I'm understanding this right, this is looking east. East is towards that wall right there. If you face that wall, you're facing east. So if that's the case, because this was a straight easterly trajectory, this is the one that popped. But I see cracks right there, at least on the outer thermal protection system on that nozzle. Maybe it's just the camera. Yeah, I don't know. It could just be paint, but you usually don't see something like that. This is coming from Max over at NSF. Oh. Yeah, right at the throat. Any ideas why the SRB separated later? On Vulcan flights, Shinar, they don't jettison the boosters right away. They tow the empty casings up to where atmospheric pressure gets lower. So when they separate them, that basically means they don't need a separator motor. They can just release the decouplers and what little aerodynamics there are, it just moves the boosters away. They always coast with empty SRBs for a second. Atlas does this. Vulcan does it. Yeah. Does Vulcan do roll? I don't think it rolled at all, Creeper. But once again. Give me 1 second. watch the video further. Oh, all right. Give me 1 second. Let me switch the scene back. Dude. All this coming off is FOD. And if any of that hit the nozzles or anything, they would have been screwed. They're so lucky that it didn't. Like, yeah, look at all the parts of the damn nozzle coming off. See all that? I saw that. That's when I started to notice something was wrong. SRB jettison was planned for 149. It occurs at 210-ish. It's because of the trajectory. The loss of thrust erudite. Everything in the timeline gets pushed when you lose your TWR on ascent. Guys, they lost thrust on that right SRB at max Q. Dude, you don't know how close that thing just came to failing. Like, I can't believe that. I can't believe that just happened. Like, you tempted fate there for sure. I see it waited until it reached the planned altitude, not time. Bingo. What'd you miss, Deathy Poo? I could go explaining it, but I'll just show you my buddy Max's footage here. Take a look. So, we just watched Vulcan Cert-2. It did make it into space. It did make it. Watch right here. Wait for it. Oh. Are you observing? See how the flames coming out of this are a nice cone, and the flames coming out of this are not? That's a problem. Yeah, that's bad. I can't believe that. Kudos to that cloud. Hey, man, they made it. They made it. I'm going to retweet Max's. Here, you guys just spell check me. Looks like the aft SR... Tori said it was SRM1, right? How about we put SRM1 aft casing? Had a bit of a funny. We never got telemetry, just callouts, and all the callouts after this, after max Q, were off time, Moist. Yeah. Bob, nice. You found a short video from Northrop Grumman on GM manufacturing. Send it? All right, cool. Hold on, I also got... You are an absolute mad lad for this footage, dude. Great job, Tim and Eric. Awesome show. We got to put exclamation points to inflect tone. What's that, Grav? Oh, snap with the baller picture. That's a great picture. It's really nice. Good. Cool. I want to see this. More paperwork for the FAA. Yeah, I started to see these sparks come off the vehicle, and I'm like, I don't think that's right, but I don't know. Oh, hang on. D just posted pictures too. This is coming from D over at NSF. This is excellent footage. Oh, with D's footage, you can see there was a roll component, guys. Look. Dude, that was a violent explosion. I can't believe that thing stayed in one piece. See? See the whole rocket.
Tranquility Base here. The Eagle has landed.
Oh boy, I sure hope nothing goes wrong with Vul. Oh god dang it, Tori.
Dude, look, it tilted the whole vehicle. Here, I gotta link this to Adrian. He was asking about this stuff. Hold on, I'll just keep playing it for you guys. I just gotta see where it... Yeah, dude, look at the whole stack. Boom. So, okay, if it put a roll rate on the vehicle, guys, that's consistent with Max's footage from where it exploded. The anomaly was over here. It was on this side of the casing, and if the casing popped that way, it's gonna roll the vehicle a little bit. Oh. See all these little chunks? Those are little pieces of the nozzle. That's all pieces of the nozzle just ablating off. Now, had this been a VC4 or VC6, would the explosion impact the other SRBs in close proximity? Yeah, Phil, they're lucky a BE4 didn't pop. Because think about it, dude. Behind there, at the bottom edge of a vehicle, of any rocket, right? Between the nozzle of the engine and the bottom of the rocket, right? It's an aerodynamic dead zone. There's actually a vacuum in there. It's super low pressure in this vacuum. It pulls stuff towards it. Phil, if one of these things popped and hit another SRB, once again, all that stuff's going to get pulled in towards the BE4. Dude, I'm not trying to be dramatic. They're so lucky that that whole stack didn't blow up. Like, that's about as close to an explosion as you're going to see without an explosion actually happening. It got to orbit. Any word on McDowell from the trajectory? I think GNC compensated fully, Hokie, if I saw that right. But you know what, dude? If we... Here. This is where I knew... I saw the sparks coming from the vehicle, and I'm like, that's not right. But I saw something. I saw something that I had seen before, believe it or not. On a different rocket, though. I saw the sparks. You could see them right there, coming off. Right? And if you... It's this next shot. See, I saw those, and I'm like, nope, something is very wrong. Look at this. What does that look like? Anybody? And I'm trying to see if you... I've seen this before. We've seen this happen with other rockets. Does anybody know which one? Yeah, Havocs, yeah. No, not Delta 2. No, not Challenger. Somebody said it. I'll show you. Yep, you guys got it. You guys got it. Here. I've seen this before. That's what a bad trajectory looks like. The IFT-1. Some of you got it. It looks like IFT-1. When you see a lot of flames coming out and the rocket not going in the direction, the rocket not look like it's going anywhere, when it's doing that, look, that means bad trajectory. I've seen this before. You predominate, you got it, and a couple of, I think Mach 6 got it as well. That looks exactly the same. See? Bad trajectory. That I saw this and I'm like, nope, that SRB failed. That's when I knew. I didn't say nothing, though. I never want to jinx a launch. We're gonna play Satisfactory today, King, but I need a break, dude. This is the most Kerbal launch ever. Look, complete casing failure. Well, not aft casing failure. Wow. On Max's footage, when the big pop occurs, you could see the BE-4 plume compensate immediately. Yeah, no, it compensated. How much thrust do those SRMs have? 2,000 kilonewtons, Jim. It's a little under a quarter of Vulcan's liftoff thrust in the VC2 configuration. Like I said, if there was payload on it, it would not have made it. It wouldn't have made it. Like, if they had, like, a 10-ton payload on there, no way. 5-ton payload, maybe. Big maybe. Oh, hold on. Kevin replied, hold on. Funny, an observation, an anomaly. How about just an oopsie? Only if it's called an oopsie doopsie. Then I'll allow it. Thank you, Ota. Cool. It's an anomaly. Oh yeah, she's great, Jim. I can't, dude. I can't believe that. All right. All right. I think I need a break from the internet. Click it? I'm not clicking that. I ain't clicking that link, Melon Farmer. According to Boeing, this is not a problem. Cope and seethe, Boeing. Happy Sputnik Day, everybody. Was it a test payload? No. What? Anyway. Oh no. Anyway. Hang on, I'm explaining something to Adrian. Give me 1 second, dudes. Adrian is wondering why the BE-4 moved in the direction of the SRB. So the BE-4 moved out to compensate. So you have your two BE-4s here. You have the other SRM. This SRM failed, and the outside BE-4 went out this way. Adrian's wondering why. So I'm explaining it to him. So it moves in the direction to compensate for the offset thrust. Basically, the SRB is supposed to be making thrust over there, and it's not making thrust over there anymore. So the BE-4 has to point in that direction and try to compensate for the loss of thrust in that from that direction. When is Spin Launch sending something into orbit? I don't know, Slow Chief. I've heard nothing from them in a long time. The BE-4 is looking like a Chad tier engine. Yeah, dude. And, still eating eggs. And there's going to be 7 of them on Newglands. Look at these replies, dude. Jack. Nice. That's funny. That's not Jack Byer. That's Jack Frodo. That guy's funny, too. It's been removed from its environment. Is that supposed to happen? I think you'll appreciate the GEM manufacturing video I posted earlier. There's a whole section on the nozzle alone. Yeah. All right, I kind of want to take a nap, guys, and then come back in a little bit. Yo, that's excellent. That is pretty damn funny. If you get the joke, you get the joke. That's pretty good, man. Yeah, take a nap when you need full power. Yeah, yeah. Give me a couple hours, guys. I'll be back at 11 noon time, all right? So anyway, I hope you guys enjoyed the Vulcan coverage. That was insane. We'll talk about this during Flame Trench. I'll be back for some Satisfactory in a little bit. And on that bombshell, it's time to end. Yeah, thanks. See you later. All right, yeah, give me 2 to 3 hours, guys. I'll see you back here at noon. Sorry, I would have just belted through Satisfactory all the way to Flame Trench, like I said, but I decided to have a nasty bout of insomnia last night and have not slept. Come 9 o'clock, I have not slept in 24 hours. So let me get a couple hours of sleep, and I'll be back for Satisfactory and Flame Trench. It'll be great. I'll see you guys then. Thank you very much for watching. And I'll see you in a little bit.